Well, we are live.
Alrighty.
You wanted to do the honors, Alex?
What was that?
You wanted to do the honors?
Yeah, I will happily do the honors. Alrighty. Hello, everyone, and thank you for joining us for our second annual Logic Apps Community Day. We're very thrilled to have you here with us. Whether you are a seasoned pro or just getting started, this event is all about sharing knowledge, inspiring creativity, and building connections within our amazing community. So we have an incredible lineup of guest speakers for you guys today from our community. They've prepared some fantastic content to dive deep into Logic Apps. They'll be sharing their insights, tips, and some real-world experiences that can help you elevate your skills and tackle your projects with confidence. So make sure to grab your favorite beverage, let's settle in, and get ready for a day packed with learning and inspiration. We're definitely encouraging you to interact with us in the chat, so your thoughts and questions are what make this community so vibrant. Definitely make sure to ask questions. We will have our speakers ready to answer them. So let's jump right in. Our very first session, let's see here. Sorry, I'm like all over the place. Let's see. Our first session, we've got Igor. Is Igor on the stream, Wagner?
No, he's not on stream, so that I think I might be a bit early to him. So you can introduce him and talk a little bit about what the session is all about.
Great. So our first session we got for you guys from Igor. The name of his session is Unleash the Power of .NET C# in Azure Logic Apps, now with extra sizzle. So Igor Shvets is the CEO of Angad 365 and is a strategic tech innovator known for advancing government and enterprise solutions with expertise in Power Platform, Dynamics 365, Azure, and AI. Igor will showcase how C# can be leveraged in Azure Logic Apps through various practical scenarios and examples.
And with no other delays, let's go to the show.
Hello, welcome everyone to the session. My name is Igor Shvets. I'm a CEO of Avangard 365, the consulting company on Dynamics product, Power Platform, and Azure. And I have a particular lab for Azure Logic Apps. So what we're going to talk today, it's how to unleash the power of .NET C# in Azure Logic Apps, now with extra season. So what's going to be an agenda for today? We're going to see the introduction of the use case. We're going to have a brief overview of what Azure Logic Apps are. We're going to take a look at the standard plan for the Logic Apps, the one that's necessary to run the inline C# code. We will see the C# inline code in Logic Apps. We will see the difference between Azure functions and C# inline code and the use cases. As always, we're going to look at advantages and disadvantages of C# inline code, and we'll have a demo and the conclusion. Going to the next slide. So we're going to look at the different use cases for the global event management and notification systems. So we're going to see C# use cases for managing multiple time zones and possibly custom reminders. We're going to see how to process large data set. We will see how to ensure secure data handling using encryptions. So overview of Logic Apps. Obviously, if you're all here, you should be aware what it is. So Azure Logic Apps is a cloud service that automates workflows across different apps and services. It integrates with the various connectors like Office 365, Azure services, and third-party APIs. Logic Apps can handle complex workflow with condition loops and error handling. And personally, I want to say that it's probably the best workflow engine in the world, used by many corporations, and we used it in many scenarios, and it was extremely robust and having enormous customer satisfaction for using it. So in order to run C# and inline, it's very important to run it as a standard plan, right? The serverless will not work. So what's the difference? It's the execution environment. So it runs on a dedicated compute environment with improved performance. It has this cost efficiency. You pay for what you use with the consumption-based pricing. The flexibility, it supports custom connectors, inline codes, and other integration with Azure services. So how to leverage C# inline code? It allows custom logic using C# code and .NET directly within Logic Apps without external dependencies. So you can use the .NET libraries for complex operations like time zone conversion, encryption, advanced string manipulations, payload processing. Inline code executes within the Logic Apps workflow, reducing latency compared to external calls. So later in the presentation, we're going to see the pros and cons of using this approach, right? Like everything else in technology, it has its pros and cons that we're going to be looking in details. Okay, so you might ask yourself, but we already have something similar. We can run the C# code using Azure functions. So it's very reasonable to ask yourself, why would you run inline code versus Azure functions? So let's look at why you would use each one of them. So let's look at the execution. Azure functions runs as a separate services. The C# inline code executes within the Logic Apps workflow. Latency, you're going to have a slight overhead due to external service call in the Azure Logic Apps. In C# inline code, low latency, executed inline. Scalability, it grows independently like a tree. And inline code is limited by the Logic App scale like a plant. The complexity, so Azure function, it's a Swiss Army knife, can handle complex tasks with different tools. Inline code, the recommendation would be a puzzle piece. It fits within embedded logics very, very neatly, right? A very important deployment. The deployment is like a satellite launch. It requires a separate mission control. So you need to hold your Azure function separately and handle it separately. In the inline code, it's onboard tool. It's ready to go without extra steps. So all you need to do, just put it as a step in your Logic Apps, and you call it a day. Security, it's obviously Azure function. It's like a fortress. It's secured with the app service features. The inline code is protected within Logic Apps, right? So it's very important to look at the use case and see when and where you use it. We'll go for the next slide. So the advantages of C# inline code and why choose C# inline code. First, it's a simplified workflow. It's all in one scenario. It keeps everything within Logic Apps. No need for the separate Azure function. It's effortless management. Focus on building, not juggling multiple services. Also, what happens in the large corporations, you can have different teams responsible for the Azure function, right? So the advantage is you can handle more simple scenarios within your Logic Apps. Lower latency, so instant execution, run codes directly within Logic Apps, cutting out delays. It's fast and efficient, experience much quicker response time without the overhead of the external calls. The flexibility, it's dynamic operation. You can tackle complex logics and dynamic tasks, right? It's inside your Logic Apps. And obviously, the .NET power. You could leverage complex .NET libraries for advanced processing. Cost effective. It doesn't come with no extra cost, so you can avoid additional expenses. No need to spin separate Azure functions, even they're not expensive. It could be an issue, and it's one-stop processing. Everything happens in the Logic Apps, saving both time and money. Like everything in technology, or maybe even in life, everything comes with advantages and disadvantages. So the disadvantages, it's obviously limited scalability, the performance boundaries. So inline code is tied to the Logic App limits. It struggles with the high volume scenarios, and it's not for heavy lifting. It's best suited for simple and moderate tasks, not massive and scalable operation. Debugging complexity. Okay, it's much harder to troubleshoot. Inline code can be tricky to debug within the Logic Apps environment, right? You need to extract the codes, you need to pass separate payloads, so it's a little bit more complicated. Limited visibility, it's less straightforward than debugging separate Azure functions. The code maintenance, it's tangled logic, so the complex code embedded within the Logic Apps can become difficult to manage. And it's hard to untangle. Workflow might get messy, making updates and maintaining them. So it's really important for a good architect to see what kind of use cases that you will use for which scenarios. And we're going to see a couple of use cases that I think it's perfectly suited for the inline code. The execution limits, so timeouts and size caps, inline code may face execution timeouts and restriction on the code size. Environment constraints, you have to be mindful for the limits of the logic app context. So to sum it up, our key takeaway: the C# inline code power and flexibility is direct integration, seamlessly handles complex logic without Azure Logic Apps. A versatile solution. It's perfect for tasks needing quick inline processing without external dependencies. It's ideal for low latency and simplicity. It's the best for scenarios where speed and straightforward workflows are essential. It has limited scalability, not best choice for high scale or highly complex operations. So Azure Functions, scalable and modular, independent of logic apps, great for more scalable modular logic that needs to be managed separately, and handles complexity, better suited for larger, more intricate processes that requires dedicated resources. So how to choose the right tool? It's balance your need, assess your specific requirements and its performance and scalability, and pick the right solution for the job. Okay, so it's going to be a demo time. All right, so let me see here. So first, let's see how it's used in the real life. I apologize in advance if the code is a little bit if the code is a little bit small. So if necessary, we'll provide the source code as extra after the session. So there are 3 different logic apps that we're going to look today. One is going to be called Test C#. It's something going to be extremely basic. So we're going to see how to code, how to call C# code within the logic apps using very, very basic scenario. So one case we're going to look is when the HTTP request is received. We have a very simple object with a first name, last name, and a date of birth. Okay. So what the C# code can do, it's able to get information from the HTTP request and process it. So what we're going to do today is we're going to take a look at the code inputs. It gets the trigger inputs. It gets the data from the JSON, first name, last name, date of birth. It can easily do very simple calculation like calculate the age based on that date of birth. It can concatenate full first and last name to make it a full name. It log information to the application insights and send you a message. Obviously, the beauty of using C# code is you have exception handling and you have the error, a very detailed log. Another beauty of it, you can keep your code separate, and as you see here, you're able to have a separate function that will calculate your age based on that date of birth that's been passed. So you can compartmentalize your logic, and then as a result, it will assemble the message that you will display on the screen. So let's see. So let's see what it does. So if I copy a payload, go here, C#, and I run it with a payload. Paste. So we have the first name, the last name, the date of birth. I click on play, and it will tell me, welcome, Julie Alcaz, you're 36-year-old. The city you provided is Toronto, in Canada. So let's look at the data further. So here we're able to process and calculate the date of birth. So another thing that we can see is if we initialize a variable and assign the value to it, and if we call and we set a variable by assigning a value with the city of Toronto, we have another C# script that will at this time not read the data from the HTTP, but also from the variable, right? So you can use it in the different places in your script, and this can pull the data and execute it. So if you look at the C# code, you have your using statements, you calling the trigger outputs, and you have your action outputs. So by getting the action outputs, you calling the set variable action that it's right before it. You get the body of this. You get the body of this of the action output. You initialize the country. You do your validation just to make sure your value is there. Check for nulls, and you say if the CD is equal to Toronto, then you will say you're in Canada, and else you're going to say it's in the US. You can log the rest of the information and return your results. So it's very simple use case. So here, what we see is that we can use the C# code from the HTTP directly. Probably in the real life, you would use compose and parse it. But just to let you know that it could be used in multiple environments, or you can read it from the variable directly. So if we run it again. Okay, 1 second. If you run it again with payload, it will show us that Julia is from Toronto. So if you refresh, like everything else in the Logic apps, you can look at the execution details. And you can see the payload you received, and you can see the details behind the execute C# script. So you have the name of the code, you see the output and extra data. So it handles just like any other Logic app action. So same for the CD. So you have hello, the CD you provided is this, and it's based on the value of the variable that you have here. Execute C#, and at the end you'll send the response that will concatenate the data and send output the value. So this is the most basic example, and we have two more that is slightly more complicated. If we go here, there is one example that's called encryption. So here we better start with the actual execution. So since we're talking about event management, I want to be able to encrypt in my payload my name. So let's say I paste the payload, and the name that I wanted to encrypt is my name here. So let me just maybe it's easier if I just remove myself. It's going to be the encrypted name. This is the one that I want to remove, right? So if I run the execution, just remember this name. I run the execution, and I have my name encrypted based on the JSON payload. So how this is done using this is done in the Logic app using inline code. So let's look at the designer. So just like before, it will get the request body and the JSON schema. So we have our parameters that we're going to put in, and this is where it becomes more interesting. You can, as you can see, you can put a pretty, pretty complex code into there. Based on the trigger, we're getting the trigger results. We're getting the body. We're making sure the body is not null. We're getting the name of the attendee. Obviously throwing the exception if we cannot find it, and we just give an encryption key. Give a very simple encryption key. It could be much more complex, but for the simplicity's sake, this is what we show. And you call the method to encrypt the string using attendee name and encryption and the encryption key. So we look at we replace the encrypted name in the payload, log the encryption process, and show the results. And the beauty here that you can have the whole pretty complex method for the encryption of the string. So you get a plain text and you get a string. You obviously verify for null or empty, and you're going to use your algorithm to iterate to replace the string with the encoded value. So if we obviously this is an example. This is a simple example. You will not going to be likely. You're not going to be putting the encryption key in the open text in your C# in your C# code. The idea here is just to show what is doable, right? In the real life, you will be hiding it and not exposing it like this. You will be injecting it differently. But the idea here is to show you that it's what is doable using the C# code and the inline function. So after this, we're going to process the data from our execution of our C#, and we will expose the response using a encrypted string. So if you look at the execution, we receive the value, we receive the payload with the encrypted name here. And the properties, we have the body of the message where the name is encrypted. We're passed a JSON based on this payload, and it gives us the formatted text that we're ready to use in our response and paste it in our response. And our response is the encrypted name. So you can store it anywhere in after and use it for your system. You can use another method to decrypt it if necessary. We're gonna have one more example, and I find this is probably going to be used the most. It's validate complex payload scenarios. So often, what used to happen in our organization, we had trouble validating a payload that was dynamic. And there are different methods for this, but I find that this inline C# code is going to be it's going to be absolutely great for it. So the example we're going to see here is we're going to have a very, very complex, well, not very complex, but relatively complex JSON payload. An idea for it is you have different sessions, you have different emails, you have different start times, you have different contacts, they can have different emails, etc. So idea is I want to get this payload and I want to make sure that all the emails are properly formatted. Okay, and if they're not properly formatted, I want to get a notification. So right now we see that all the emails are properly formatted. So if I run the execution, I say all emails are valid. So I'll close it. So let's run it again. let's go here. Let's find one email and let's just remove the com. Very realistic scenario. We'll run it. It will tell me that there is invalid email format for the Emily Taylor. Okay, so situation like this happens very, very often, and I find that using the inline C# code it's an amazing tool for this use case. So let's see. Let's look behind the scenes. So let me just maybe increase it a little bit. So just like everything else, we have our JSON schema. We have, as you can see, fairly complex schema. And we have our C# code. Okay. So what do we have? So we have our trigger inputs. We extract the full JSON body. We have the list of, we're creating a list of all the invalid emails. After what we're going to do, we're going to validate email in the event organizer contacts. So we're going to iterate through the structure. We're going to look at all the contacts email, and if any of the emails are invalid, we're going to add it to the list. Also, for the other nodes, we can validate the emails in the sponsor contacts. We can validate email in attendees. We can validate emails in the session speakers. And later, what we're going to do, we can return results based on validation. So if there is count of invalid emails is above 0, then it's going to return us a new object stating that the emails are invalid. Or else it's going to return the valid object. So also you can use, again, non-trivial C# logic using the regular expressions to make sure if the email is valid or not, right? If something is not correct, you will catch an exception. So I think in about 110 lines of codes, we're able to get a non-trivial payload and validate multiple nodes against the regex to make sure that our emails are valid. So the same things obviously you can do for phone numbers, you can do maybe for addresses, you can do any kinds of validation. So, and as you can see, it also runs pretty quickly, and you do not need to worry about anything. Just put your inline code, parse the information, and the magic will happen. Okay, so if we look at the execution, just like before. So when we have HTTP is when HTTP is received, we're getting the headers and the body. So we take all this information, we put it in our C# code. We have just like everything else before, we have the inputs and the outputs. It tells us that the email is invalid, and we have the property and the session. And once this is done, we have the response for our HTTP call. So as you can see here, we've seen three different examples. First is our test C#, very simple example that you can use it for very simple use cases like get data from HTTP, calculate the age, and run very simple conditional statements based on a variable. In the logic app number 2, for the encryption, we've seen that we can take a string and we can encrypt the string using using our encryption methods that exist in C# and .NET. And the last but not least, we've seen how to validate complex JSON payload to make sure the emails is correct. Now, obviously, it can get much more complex. There are other fields you can validate. You can also validate a structure of your JSON payload. Let's say if you give yourself a very permissive schema, you can use C# to validate, to give it extra level of validation. And you can use a conditional treatment based on this, based on the results of the schema that you have. So this is what I had to show for today. Those are our 3 samples. I would like to thank organizers for the opportunity to present, and wish everybody a great day or evening or morning. Thank you.
Well, thank you, Igor, for that session. It was really, really good. C# inline C# is quite new, and we can see for the number of questions in the comments that was something that people was really, really interested. So next up we have Prashant Kumar with his session BizTalk to AIS Migration, Learning from the Field. So Prashant is a solution architect at HPE and specializes in application modernization and integration using Microsoft technologies. He also quite an active content creator, creating content for blogs and videos. So what he's going to be doing on this session is going to be sharing his experience about planning and best practices for migrating from BizTalk to AIS based on his own experience in the field. So without further ado, just let me find his session and add it here for you.
Hello everyone, my name is Prashant Singh. I'm working as a solution architect for one of the MNCs. I got chance to assist many companies in their BizTalk to AIS migration journey. I'll be today, and that is the topic of today's discussion as well. I'll be talking about why to migrate, BizTalk to AIS mapping, and the learnings from the field. So hope this topic helps in your journey as well. So the very first question which we ask is why to migrate, and what are the benefits of migration? So because Azure Integration Services is conceived in cloud era, and therefore it's super feature loaded. The first thing is the REST APIs based integration, and that is one feature where you can design your systems as APIs and all that, and as well as you can consume your partner or consume other applications. It allows you, provides you a highly scalable cloud infra. It also provides you with modern authentication and enhanced security features, and ease of integration with other cloud native services like APIM, WAF, Defender, Sentinel, or ADF, and so on. So the ease of integration with all other Azure services is too much. It also allows you consumption-based pricing. So therefore, you pay for what you consume. The single tenant pricings are extremely affordable, and that also helps a lot. Because the pricing is so convenient, apart from that, it is almost a no code, low code experience for developers. Most of the development you can even do via Azure portal, right? So it allows you to experiment quickly, fail fast, fail cheap, and succeed big. So that is the mantra for AIS. It allows you for SaaS connectivity, quick integration with SaaS companies, whether it is any third-party systems with your ITIL or any other third-party companies, that lot many connectors are there, and therefore that SaaS integration is very, very fast. The last but not the least, because AIS is spawning over 60 plus announced regions, therefore you can choose to deploy the services as closer to your customers as possible, and therefore all these benefits in all provides a very good reason for you to migrate to AIS. So in general, whenever we talk about integration, there are some key things which are present in all the integrations. You generally have some workflows where you talk about the first I need to do this, then this, and then there is a workflow which needs to be followed. Then you have some events, right, where if this happens, then another thing should be followed by that. You have some ETL sort of scenarios where you extract data, transform it, and finally load into some other systems. Then you have some APIs which either you are consuming from your partners, or you are exposing yourself as an API, right? And finally, you have some messages which some information which needs to be transferred from one system to another system, and all this we'll see how AIS solves it. So in case of AIS, the workflows are part of logic apps. So whenever you want to design or automate a system where you can think of a workflow system, if this happens, then these things should be followed. So that is where you should go for logic apps. Event Grid is something where whenever you talk about generating events. So for example, some message came into a blob service, or maybe a virtual machine is turned on or off, or any event which you can think of. If you want to have some event driven solution, in that case you should choose Event Grid. Data Factory or Synapse should be chosen if you have a message size which is bigger size, and you want to extract data from multiple systems, transform it, and load it to a system. It is kind of a replacement of not replacement in SSIS cloud counterpart is ADF. API management, as we all know, you will be able to publish your APIs or consume other APIs. It also allows you a developer portal through which your customers can come and try that on and you can expose your legacy APIs with OAuth 2.0 or other modern security features and all that. Azure Function is where if you want to write your own some custom code or some serverless APIs, so Azure Function is the place to be. So what to choose when is also a very, very critical thing which you should decide here, whether you should go for logic apps or ADF or what. These are the reasons why you should choose which technology. As we are talking about BizTalk to AIS migration, we should also talk about what are the key features which are there in BizTalk. It definitely has a messaging system where we are publishing something into message box and then subscribing on the basis of either content or context, right? You have some workflows or orchestration services which are there in orchestrations. Similarly, we use BREs for rule-based operations. You use BAM for business activity monitoring or tracking some business related information. Similarly, you use HAT or health and activity tracking for overall logging and tracking of your messages. And SSO is something which is used for security purposes, where you want to save some encrypted information and all that, right? So we use single sign-on for that. So we will try to see how these services or things are mapped into AIS. And here I'm talking about what are the BizTalk capabilities and how they can be mapped into Azure Integration Services. So the moment you talk about message routing, where you are publishing and subscribing messages, in that case, Service Bus or the Event Grid, if you want to go for event-based things like a file is dropped into a file location or SFTP based. So in that case, event-based, event-driven mechanism will be there, and that is where we have to use Event Grid or Service Bus in case of you want topics or subscriptions, publish and subscribe sort of architecture, right? If you have BizTalk maps and you're using it, so you can keep it into integration account and use them as is. So that is where we are talking about the reusability component. In case of Logic Apps standards, now we don't even need integration account. It can be part of your Logic Apps itself artifacts, and there you can directly use all your BizTalk maps. In case of your pipelines, the inbuilt pipelines, we might have to write Azure functions for that. However, if you have some DLLs like custom pipelines or something, that can be not as is reused, but can be the logic can be reused by putting it into Azure functions or something. Similarly, if you talk about adapters, which allows you to connect to different systems like SQL, SAP, and so on. So in that case, we in Logic Apps we have too many connectors for that, and uh, which allows you to connect to any system, any third-party system, and fetch or perform operations to that particular system. So we have connectors for that. For workflow, in BizTalk we used to have orchestration. So same workflow design or definition can be rewritten in Logic Apps. For BRE, AIS has recently launched a BRE operation means the feature, which can be, although it is in preview, but definitely you guys can look into it. If that doesn't suffice, we can also write Azure functions which can be using the app config of AIS or the app config in general, right? For BAM, uh, uh, by default, there are Logic Apps or Function App. They all have their own tracking capabilities where the messages are tracked along with the body if all those features are there. So by default, they allows you for a very what do you say, helpful tracking information. But you can also go ahead and develop your own integration logging end-to-end logging framework, which I'll be talking in one of our slides. The APIs, we'll be using API management for exposing ourselves as a service or consuming others. So that is extremely good product which is available. What are the learnings from this from the field? So first thing which we should know is BizTalk is not at all equals to Logic Apps. In case of BizTalk, there was just one product where which was kind of sufficing all our needs. However, in case of Logic Apps, we'll have to choose which product solves our needs. So whether we should go for Logic Apps or ADF, we'll have to decide. Similarly, there are so many options for queue. Should you go for service bus, or you should go for a storage account queue? We'll have to explore them all and choose what best fits our solution, right? Similarly, whenever you are designing, because we are getting chance to redesign or re-architect our solutions, so the approach should be very different. Our mindset should be cloud first mindset, and there are multiple for example, you should design for failure. So you should think about async instead of synchronous solutions. You should think about redundancy. How if even if your one node or two node goes, how the other node should be able to take the load and process it. What about the failure mechanism? What about the recovery? You should think about RTO and RPO and all that. So design for failure and design for scalability. In that case, your application should be automatically scalable vertically or horizontally without any design change or manual interventions. Similarly, automate your managements using IICs, CI/CDs, or ARM templates. You should be able to build self-healing mechanism in your application. You should have proactive monitoring and alerting mechanisms, so that whenever something goes wrong, you are proactively informed about it, so that your supporting can take actions on the basis of that. You should think security should be ingrained in your design. You should think about RBAC for giving permissions. You should think about encryption and so on. For example, instead of using SQL connection string, you should think about how I can give permissions to RBAC. How can we use app registrations and all that? Cloud native patterns like serverless or event-driven services or containerization microservices. So these are the things you should be looking at. Design for visibility, because the data is the new oil today. So you should design a system so that you should have a mechanism to recognize pattern which are helpful in your business scenarios, as well as it should help you in issue detection and proactive monitoring. We should also look for well-architected framework, which is the Microsoft suggested pillars, which is talking about reliability, security, cost optimization, or operational excellence and performance efficiency, right? So you should be thinking about all these things, because you are getting chance to redesign or redevelop your system. Automated testing is a must. You should think how you can, using Azure DevOps, you can automate your testing functional load. So every time a developer checks in the code is thoroughly tested. So these things are a must to have in any system which you are designing. There are a known limitation of each and every product, that is with respect to the size or number of messages, or with respect to the time. And you should, these things are limitations are changing every day. So you should review the known limitations and design your systems as per that. There are few scenarios which definitely you should kind of in those scenarios you should redesign. For example, a low latency scenario. So if you want a low latency scenarios, in that case you should think about redesigning. Or if you are using large messages, in that case you should definitely think about redesigning and re-optimizing high throughput and resumability also. So let's say if something goes wrong, you should be able to resume. So for example, if you are using ESB in on-prem system, we had that capability of resuming if something goes wrong. So that things you'll have to redesign here, because in some or the other way. In short, the planning is the key. The first thing you should think about is you'll have to plan it end to end. So first thing is, what sort of migration strategy are you going to choose? Whether it will be a lift and shift where the benefits are least, but so is the risk, or are you going for migration or redesign into completely, right? So that is the first thing which you should think. What are the components which can be used? For example, your maps can be reused, your libraries can be reused. Similarly, think of what things can be reused and what things needs to be redesigned completely. Divide and conquer. So on the basis of your complex applications complexity or criticality or the value it brings, divide the applications into multiple boxes, and then do a phased migration. Divide your teams of developers who are going to help, or the architects and managers, because in the every process, for example, your testers should be ready so that they are able to test the application, right? And the best is to go for iterative approach, where you start small, do some POCs, and validate if everything goes good, then go for phased manner migration. The last but not least, whenever you're going for designing your system, first thing is you should build a landing zone before even moving your first application. So end-to-end logging and monitoring framework is a must, because every component, whether it is logic apps, function app, or anything, they have their own monitoring capabilities, but your message flows from multiple systems. There will be multiple scenarios in which your message flows from logic apps to function app to APIM and so on. And there should be a mechanism there where you should be able to trace it end to end from start to end, using some or the other way. And that is where you should design your own custom end-to-end logging and monitoring framework. I'll be talking about one in some time. You should be using DevOps for the whole process. Simple boards will help you in the planning, where you're keeping your source code, Git and all that, the pipelines for doing the CI/CD, or even running your test cases, right? So DevOps is a big help for sure. You should, as I talked about security, you should be ingrained in your design. You should think about RBACs, authentication and authorizations and all that. Data at rest, how do you secure that? So you should be thinking about that. Exception handling and error handling scenarios, and how you're going to alert, create a ServiceNow ticket or any other ITIL ticket, so that your service team is informed to take actions, and so on. And finally, the testing. Plan for testing. Plan how you are going to do unit testing, functional testing, or load testing, because that is very, very important, because it's very much different from, BizTalk is very much different from your AIS environment. Therefore, testing is a must thing. Leverage Logic Apps test framework. It is extremely helpful. Write your own test cases for function apps or logic apps. And in every run, this should be validated. Every time a developer is checking in the code, those test cases should get executed. This is the framework which I was talking about, end-to-end logging framework, and you can read about it more in my blog. So in this framework, what we try to do is we have created event. We have categorized things as event producers, which will be generating events, logic apps, your function app, or web applications. These are the events which will be generating your events. All these events are getting into event hubs because it allows millions of records to come inside and then publish to the subscriber. So therefore, we are using event hubs here. And either your logic apps event producer should be directly able to push events into event hub, or via function apps or any class libraries, they can push messages into event hub. And then we'll have to design some event consumer. In our case, we designed a function app which will be picking all these events from event hub and then pushing it into either Azure Monitor or a SQL Server table or anywhere. And so therefore you will have a track of all the information, which is all the events which are coming, and this can be used for logging purposes or tracing purposes or even alerting purposes. And on the basis of these SQL tables or log analytics tables, we can go ahead and create our own workbooks or maybe write fancy web pages also. And this will be one of the best thing which you have done for your AI solution, because in using this, you will have there is one place where you can look by some correlation ID or tracking ID. You will be able to track the whole journey of this message end to end. Yeah. So that brings me to the end of this presentation. So thanks a lot for being till here. You can contact me with any of these mediums. You can contact me via LinkedIn, mail to me, or follow my blog. Thanks a lot. Have a good day ahead.
Well, thanks, Prashant, for that session. It's like the BizTalk is always a complex scenario to look at, and migrating from BizTalk is quite important. So thanks for all the insights. And Alex, I pass it to you for the next session, and all yours.
Great, sounds good. Our next session we've got for you guys is from Sebastian Meyer. His presentation is going to be on seamless SAP integration with Azure Logic Apps. So Sebastian Meyer is an experienced consultant, coach, and trainer at Quibic with over 15 years in the IT industry, specializing in integration projects. Sebastian is also one of the founders of Aviators Germany and was recently awarded the Microsoft Azure MVP for his efforts in the community. Sebastian Meyer will demonstrate how Azure Logic Apps can streamline and enhance the integration of SAP systems with cloud services. All
Okay,
right.
so let's bring his session.
Welcome, everyone. Welcome. Thanks for having me on the show today. My name is Sebastian. I'm working as a solution architect for a Germany-based company. It's called Quibic. Quibic's focus is doing integration projects using BizTalk, AIS, or SAP Integration Suite. And today, I want to talk about the seamless SAP integration with Azure Logic Apps. What I want to show you today, just a quick overview. First, I want to show you the importance of SAP integration. Then I want to show you which SAP versions you can use to integrate with your Logic Apps. Then I want to show you which Logic Apps deployment model supports the SAP integration. After that, I will come to the SAP connector. SAP connector is a prerequisite which implements the protocol to access the SAP. Then we will come to authentication. Then I will show you some scenarios. And at the end, I will show you a little demo where we see everything in action. Let's go. So why SAP integration is important. 77% of the global transaction runs over SAP systems. 86% of the Fortune 500 companies are using SAP systems. And 98% of the top 100 brands are using SAP systems. As you can see, these are remarkable facts. And so this leads us that SAP is a leading provider of enterprise resource planning software. And therefore, integration platforms needs the capabilities for SAP enterprise integration to be successful. And therefore, Logic Apps is an integration platform you can use to integrate your SAP systems. And this leads us to this next slide here. When you want to start your SAP integration journey, you need one of these supported versions that you can use with Logic Apps. You can use on-premises and cloud-based HANA-based SAP systems, such as S4HANA, but you can also use the classic on-premises SAP systems, such as the R3 system or the ECC system. So if you have one of these supported versions, you are able to start your journey of integrating your SAP systems using Logic Apps. And to start, you need the right Logic Apps deployment model. And in this case, the Logic Apps consumption on the left side, and also Logic Apps standard deployment model supports the integration of the mentioned SAP systems before. So in the middle, you can see we have the S4HANA system, cloud-based or on-premise, the R3 system, or the ECC system. And as you can see, you can run the SAP systems in a public cloud, in a private cloud, or in an on-premise private environment. So when you want to use Logic Apps consumption to integrate your SAP workflows, you need to use the managed connector to connect to SAP. So in this case, you are on a multi-tenancy mode to integrate SAP. And if you want to use the SAP, in many cases, the SAP system is in a private network, so it's not in a public network. You need to use the on-premises data gateway to connect to the SAP system in these private networks. I prepared a slide for this. If you don't know what the on-premises data gateway is, as you can see on the left side, we have the Logic Apps consumption deployment model here. We have our workflows. And if we want to connect to our SAP systems, you can see at the top here, it's the S4HANA, R3, or ECC. We need to install the on-premises data gateway in the near of this SAP systems. In the near means when we install the on-premises data gateway, which is a software which comes from Microsoft, you need to install it in a network where you can reach the SAP systems. So that means on-premises data gateway needs to be installed on a server which is near or in the same network of the SAP systems. Then when it is in the near, you need to ensure that the on-premise data gateway can reach the SAP system in your networks. And the communication is based on relay services. That means Logic Apps consumption will place a message inside of the relay, and the on-premises data gateway will subscribe to these messages and will then execute the command inside of the message inside of the relay here. So this is the communication between your Logic Apps consumption and your subsystems. If you want to use the Logic Apps standard deployment model, you can use the built-in connector to connect to SAP. In this case, you are in a single tenant mode, and there are a lot of advantages to use this built-in connector. Maybe there's or a larger limit size of message size over 100 MB, and a lot of other advantages here when you use the built-in connector. And another thing here is you do not need to use the on-premise data gateway. You can use the VNet integration capabilities to connect to your SAP system in private networks. I also prepared a slide for this. So this is the VNet integration slide here. As you can see, the supported systems, the S4HANA, R3, or ECC, are placed in a public cloud, private cloud, or on-prem environment. But in this case, the Logic Apps standard are also deployed in a virtual network. And the main thing here is that we need a peering between the virtual network where the Logic App standard is deployed and where your SAP systems are living. So if you have this peering, then Logic App standard is able to connect to your SAP systems, and also your SAP systems, we will see that in the scenarios later on, your SAP systems are able to connect to the Logic Apps standard. So to use one of those deployment models and one of those connection models, we need some prerequisites. And this prerequisite is the SAP connector, which is maintained by SAP itself. Right now, we have the version 3.1. It's called the NCO connector. NCO are libraries, and these libraries for Logic App Standard, for example, are part of the workflows. We will see in a minute what that means. And the subconnector for the Logic App consumption model needs to be installed on the OPDG nodes. I've also prepared a slide for this to make that a little bit clearer. And I also have a link here if you want to have a look on the documentation for this subconnector. So as I said, the subconnector in Logic App Standard will be included in your workflow app. That means, as you can see on the screen here, as an artifact under assemblies, we need to provide these libraries, and then the workflows can make a connection to the SAP system using these libraries. If we want to use the subconnector in the Logic Apps consumption deployment model, it's a little bit different. As you remember from the slides before, for the Logic Apps consumption, we need the on-premises data gateway installed on the server in the near of the SAP systems. And the special thing with an on-premise data gateway is that you can run the on-premises data gateway in a cluster. So that means you have multiple nodes with the on-premise data gateway installed. And to connect now from a Logic Apps consumption to your SAP system, you need to install the subconnector on every OPDG node. That's the meaning of this little bubble here. So that's very important to install the connector on every OPDG node. So when we have the prerequisites, the next thing we need to think about is authentication against our SAP system. I don't know any subsystem which is open to public, so we need to authenticate against SAP. There are two methods we can use from Logic Apps. First one is the basic authentication, and with basic authentication, we only need to provide a username and a password. And a more secure one is the SNC connection, which is the secure network connection. And this connection uses an X509 certificate, and the encryption and decryption will be done by a private and by a public key. So the SNC connection is more secure than the basic connection. So we have talked about the prerequisites, and we already know how to authenticate against the SAP system. Now we want to have some scenarios with Logic Apps. And we have we have two main scenarios. First scenario is receive messages from SAP, and the second one is send messages to SAP. Let's start. Or firstly, not start. With receive and send, we can use this communication types here. The first one is the RFC. This is a remote function call. The second one is a TRFC, which is a transactional remote function call. The third communication type is BAPI, which is the business application programming interface. And the last one is the IDOC, which is the intermediate document, which is a flat file or an XML file. All the other communication types are mainly XML based, but can have a look later what that means. There are also some approaches when it comes to receive messages from SAP systems. The first one is a RFC-based approach. The second one is an API-based approach. And the third one is an event-driven approach. And on the next slides, I want to show you more details of these approaches. The first one is receive messages. In this case, it's a RFC-based Logic Apps consumption. So this is the RFC-based approach with Logic Apps consumption deployment model. As you can see, we have our SAP system on the left, and we need to use the on-premise data gateway in this case as well. So receive messages means we want to receive messages in our Logic App consumption from SAP. This is the direction. Receive messages means we want to receive messages in Logic Apps consumption here. And what we need to do is here, we need to configure a trigger when a message is received. And this trigger is an RFC destination in our SAP system. That means we have a program ID here, and the program ID is, as you want, the subscriber to data which comes to this RFC destination. And the data flow, well, when SAP sends data over this RFC destination here, it needs to go through the on-premises data gateway, because the way back to the Logic Apps is exactly the same as we want to connect or send data to SAP. When we are talking about Logic Apps consumption, we need to have this on-premise data gateway in place, and it's exactly the same. Then there's a relay which is used to send the data to our message trigger here. It's a little bit different when it comes to the RFC-based approach in Logic Apps Standard. Here's the case. We have this VNet peering in place. So this is a VNet integration here. And then we can have a direct connection from the subsystem via an RFC destination to our Logic App workflow, which is hosted in a Logic App Standard workflow or in a Logic App Standard app. Trigger is the same when a message is received. There's also a program ID and so on. And over this program ID, the RFC destination is connected. And as you can see, this is not that complex with this or as the approach with the on-premise data gateway, because much less components are active in this approach here with Logic App Standard. Then we can also have a receive messages scenario, which is API based. And in this case, SAP is using an HTTP destination instead of an RFC destination. And then we can have, this is optional, we can have an API management in between our Logic App and the SAP system. And in the API management, we have exposed an API, and the data which comes through this HTTP destination is then forwarded from the API management to our Logic App, where we have the when HTTP request is received trigger. So that means this Logic App is HTTP enabled, and we can expose our Logic App inside of the API management. And this approach is for Logic Apps consumption and for Logic Apps Standard exactly the same. That's the reason why we only have Logic Apps here. And the third one is the event-driven based approach. And the event-driven based approach is the following. SAP sends, or in our SAP system, there's an event created. In this case, it's called sales order created. That's our event. That means that SAP is our event source. And via the SAP event mesh, which lives on the BTP, the event, sales order created, will be published to our event grid partner topic. So that means event grid is our event broker here. The special thing here is that SAP is a third party or a third party partner topic, which you can directly span inside of the Azure portal. So you can create an event grid partner topic and you can connect your SAP or the event mesh directly. So you can couple it together inside of this configuration. And inside of this event grid, you can have a webhook to the Logic app, which is the when an HTTP request is received trigger. So that means that our Logic app is the event subscriber in this case. And that's exactly the same for Logic app consumption and also for Logic apps standard. So now we talked about the receive messages scenarios, but we can also send messages to our SAP system. And we can, as you seen on the previous slides where we are talking about this communication protocols, you saw we can use RFC to call a function in SAP. It can be a system function or it can be a custom function called to the subsystem. On the other side, we can send IDOCs. We can also receive IDOCs, but now we are in the send scenarios. You can send an IDOC directly to the SAP system. And an example is here, you have an order, it's an orders 05, and you can use this orders 05 to send it directly to the SAP system. And the last thing here, you can also send a BAPI, and with a BAPI, you can call a method in SAP. And that's also what we want to do in the demo right now. And in this case, you can call a BAPI that create a sales order. So this is the send message scenarios. And these send message scenarios are the same for Logic Apps consumption and also for the Logic Apps standard with this specific communication patterns to use with OPDG or with the VNet integration. So to show you this live and running, I created a little demo and I want to show you the Azure portal, want to show you Visual Studio Code, and I want to also show you the result in the SAP system. Let me explain our demo scenario here. We have an S/4HANA system, which is provisioned on Azure in its own VNet. We have our Logic App standard workflow, which is also created in an own VNet. And both VNets are peered to each other so that the systems can communicate with each other. So this is a very important part here, the peering. Our Logic App standard has an HTTP trigger. So that means when an HTTP request is received, then our Logic Apps or our Logic App or the workflow especially will then be executed. And we have a business partner that sends us a sales order. And this sales order will be sent by post over HTTP. And the body of the message, which will be sent to our workflow here, this is the sales order from our business partner. And it's an XML. So this is the scenario, and this I want to show you, and therefore I switch over to the Azure portal right now. Let me start with the prerequisites. So we are in Logic App standard here. That means the subconnector needs to be as a part of the artifacts here. And as you can see here under assemblies, I've provided the necessary libraries. You can see it from the documentation, which libraries are needed. So this is the first prerequisite here. Then we will have some schemas. We'll show you that here. These are also some artifacts. I can go up here. That means we have a request XSD schema. So the request XSD is what our business partner will send us. And then we also need the BAPI structure. So that means we are able to generate a schema from SAP. And then you can say you want to have this bus 2032 sales order schema. And then you can download the schema directly from SAP. And then you can upload this schema here in your artifacts, and especially here in the schemas. And then we need to solve one problem, because the request and the BAPI are not the same. So we need some kind of transformation. And for this, we have a map here, which executes this transformation. So that map is called map request to sales order BAPI. I will show you in a minute in Visual Studio Code how to do this with a data mapper. But for now, these are the prerequisites we need. And now let's go over to our workflow here. So as I said, our workflow here has an HTTP trigger, and the only method allowed here is POST. That means the business partner can only use POST to send data to us. In the first step, we want to validate the XML payload coming from the business partner. So that means we are using the body. So this is the payload from the HTTP request, and we want to check it against our request schema. So you have a drop-down with all your artifacts, and then you can select the artifact you want to check here. In this case, this is the request coming from the business partner. And if the XML is mail-formed or the XML is not valid, then we send back a bad request response to our business partner, and with the error message that your XML is not valid. I show you in a minute how that works here. If the XML is valid, then we go here, and then we have this transform XML scope. So as I said, we need to transform the request to our BAPI request. That means in this transform XML, we are using the content. So this is the payload, which from the HTTP request. And then we are calling this map here, which is also an artifact I showed before. This is also a dropdown. If you have multiple maps, you can select the map you need to have here. And after the transformation, we want to do also an XML validation for our BAPI. Exactly the same as you've seen above for the request. We can do it with now the validation with our schema for the BAPI. So, and if this is successful here, we have then the SAP scope. And in the SAP scope, we need to create a stateful session. So here we do not need any other options. I also created a connection here to my S/4HANA system. We can change the connection here. We can also create a new one. And you have seen this here for the demo purpose here. You can set a connection name. Then you need to specify the client. Then you need to specify if you want to use basic authentication, or you want to use the logon using SNC, so secure network connection. In this case, it's basic, so then you need to specify the SAP username, your SAP password, the logon type, then the address of your application server from SAP, the service, and the system number, and that's it. And then the Logic app uses the subconnector, as I said before, and then it creates a channel to communicate with a SAP system. But for now, we have this connection in place, so we will use it. Well, as I said, for the BAPI, we need a stateful session because we need to transmit, or we need to commit the BAPI when it is inside of SAP. But we will see in a minute here. So after we create a stateful session, we can perform our BAPI call. The BAPI call is the we can use the BAPI action, and then we specify that we want to send this specific business object here, which is the bus 2032 sales order. And then you can say we want to perform this method here, sales order, create sales order. And what we need to specify here is our BAPI XML, which is the representation of the schema which is used to call the BAPI method here. And this is the output from our transformed XML output from here. This is the transform XML result. And if our BAPI call is successful, we can commit the transaction. So this is the reason why we need this stateful session here. And because we want to commit the transaction inside of this session ID, which comes back from the create stateful session. If we have an error during our BAPI call, we need to roll back the transaction. So we need to specify ran after. So that means BAPI call has failed. Then we can have the exception handling here. And inside of our exception handling, we can roll back the transaction. It's exactly the same. We only roll back the current open session. And if the BAPI call is successful, we can send a successful response. And in this response, we only say your order was stored successfully. And we also extracting the order number from the BAPI response to send it back to our business partner. If there are any questions or something else, then the business partner has an order reference for the sended order. And that's all in our case here. And so now let's jump over to Visual Studio Code. As you can see here, this is the project inside of Visual Studio Code. So here you can use Azure Portal or as well VS Code to create your workflows. And then when you're using VS Code, then you can deploy it directly to the portal. Right now, as you can see here, we have the schemas here, the BAPI schema, the request schema, and also a type schema, which is used from the BAPI schema here. And I also told you that we need a transformation. And for this, you can use the data mapper. And inside of the data mapper, let's show you here, you can specify a source schema and you can specify your destination schema. And then you can use drag and drop to connect the nodes from the source to the destination. And if you finished it, you can generate an XSLT from your map here, and you can also run a test directly from here. So we can do it here. So this is our request, which comes from the business partner. And then you can click on test. And then you can see the output directly in the window here. And this is the BAPI call we want to send to the SAP system. So this is just a quick look on the data mapper here. Right now, I want to perform a request. So now we are using the REST client inside of VS Code here. This is the endpoint to our Logic app with the HTTP trigger you've seen before. Then we need to specify the content type of the payload, which is application XML. So right now we are simulating the business partner. So I am the business partner right now, and I want to order the following, which you can see in this sales order XML here. So for the quantity, I change from 10 to 12. And for the first, I want to have a non-valid XML. So I will remove the bracket here. So this is a non-valid XML, and then we can send the request. And as you can see, your XML is not valid. So it's the XML validation state or the XML validation action which turns into an error, and therefore we are using the first exit here. Let me show portal. Exactly the first exit here because the XML is not valid. Now let's fix this. So positions and send it again. Send request. So now we should have a successful response. And as you can see, your order was stored successfully. And we also got this order reference I said before. Now we can use this order reference. It's 5669 and go to our SAP system. So I will switch to the SAP system right now. So now this is the SAP system. And here I go to the transaction VA03, which shows all sales documents. And now I can use this 5669, which is the order reference. Hit enter. And now you can see this is exactly the sales order I sent to the SAP system via the Logic app. So this is the order quantity 12. I changed this from 10 to 12. The delivery date is today's date, but nevertheless, you can see the data is inside of the SAP system here. So let's switch back again to the Azure portal, because I want to show you how you can debug or how you can view failed runs or successful runs. So therefore, you go to your workflow and then you can click Overview. And inside of Overview, you can need to zoom out. And as you can see, we have one failed and one succeeded. Let's click on this failed. And the expectation here is that the failed has gone the way with a bad request. As you can see, the error message is invalid template. And you can see our Logic app is gone on send bad request response. So this is the reason why it is on failed. And the other one, which is the succeeded one, also have a look. Here you can see everything is green. And you can see where the flow was going. And you can also see the elapsed time on a specific action here. And to find, for example, bottlenecks or something else. And then you can see we have a success response here. Yeah, that's the demo with Logic App Standard. Let's go back to our presentation. Yeah, that's seamless step integration with Azure Logic Apps. And feel free to ask any questions. Please use the chat for this. Let's connect on LinkedIn. You can see the URL here. And if you want, you can also join the Aviators Germany community, which is a branch of the Logic Apps community.
Thanks, Sebastian. That was a really nice presentation. SAP is one of those systems that if you're not actually working on a project, it's really hard to have access to look how it works. So it's really, really good to have that in-depth going through all these steps on how to connect, how to get access to that, and how to create those basic communications. Okay, so continuing, we have our next session, and that is going to be a lightning session, right? A really small but quite interesting one. And that's coming from Luis Rigueira. So Luis is an integration developer at DevScope with expertise in Azure Integration Solution and BizTalk, and is a seasonal professional known for his work in cloud solutions and being an active content creation. You find him creating his own blogs, partnering with Sandro Pereira, also from DevScope, on the Friday tips. And that is going to be one of the Friday tips that Luis gave us. The name of the presentation is Workflow and Trigger Expressions Can Help Monitor Your Logic Apps. And what Luis is going to be showing here is how to use simple expressions that can be really powerful when it comes to stay notified of what logic apps are failing and give us an information on which run, or what is the start type, and the logic app's name. So pay attention to this tip. It's going to be a short session, but I think you guys are going to enjoy it. And with that, let's start the show.
Hello everyone, my name is Rigueira. I'm an integration developer at DevScope, a foodie, a travel lover, an AI enthusiast, and a Lord of the Rings fan. Today I'm going to talk about something very simple yet very effective: the use of the workflow and the trigger expressions inside logic apps, with the purpose of using these two expressions to help you monitor your logic apps when they fail. Let's consider a scenario where you have multiple logic apps operating. In these cases, knowing the failed logic app name, run, and timestamp of the occurrence is very important. Let's say that in each of them we are using a try and catch scope for monitoring potential failures. And to exemplify this, we created a simple logic app starting with: when a HTTP request is received trigger. Next, we added a scope named scope try, and we added an HTTP connector. The HTTP call intentionally fails. The same can happen with API calls where issues can occur, leading to failures or timeouts. Knowing about these potential failures, we added a catch scope, configure its run after to activate under specific conditions. The idea is to ensure that this scope only executes when the scope try has timed out and the scope try has failed. But to understand the use of these expressions before we go any further, this is the result of these individual expressions if used alone in a compose or a variable connector, and if a run has occurred. The purpose of these expressions: the logic app name. These expressions is used to get the name of the logic app, which corresponds to the name of the workflow. The logic app run. These expressions is used to get the run ID of the current run executed by the logic app. The trigger start time. The trigger time expression formats the trigger start time by removing its milliseconds and replacing the t between the date and time with a space, resulting in a more readable format. When integrated, these expressions facilitate the monitoring of your logic apps, providing crucial details. And to complete the process, we added a response. Next, in our response, we dynamically select the outputs generated by the compose action. Now we can test this scenario using Postman. The result is precious information that can help us save time and make our logic apps more efficient. Knowing this, instead of a response, we can use another action to notify us of the failed logic app. And to complete the process, we added a send email action from the Office Outlook to be notified. But you can have other options here, like adding this info into a database or a storage account, etc. With this logic app now configured, we'll receive notifications whenever a logic app fails, including details such the logic app name, which run, and the trigger that has occurred. This information is highly adaptable and can be applied in many areas, such monitoring systems, analytics, resource optimization, or quality testing. And with just two simple expressions, we can easily set up alerts to stay updated on the logic app failures. Thank you all for joining me in this short session.
I said it was a light session, right? But it's really interesting that kind of information, grabbing information from the metadata of logic apps to help support and help the people understand exactly which logic apps fail and how to get access to that back in the system is quite important. We have actually one of our presenters here on the studio. So Mattias' session usually is quite different. Is all on the whiteboard, which I love, right? And then because of that, there's nothing better than having him to introduce himself, like different from the other sessions that we had so far. Hey, Mattias.
Hello, nice to be here. Happy to be here. Cool. And as you said, we're going to have a whiteboard session coming up. So I hope all of you is going to enjoy that. And we will talk about network.
That's really good. Can you, just for the people, like the few people that might not know you, can you say a little bit about who you are and what we're going to be seeing today?
Yeah, sure. My name is Mattias Lögdberg. I'm working at a company called DevOps Solutions based in Sweden. And I've been into the MVP community for quite some time now, so hopefully you've seen me in different areas. Otherwise, happy to see you now. And if you have any questions regarding this, please reach out and I'll try to help you out. So today we're going to talk about maybe, I'll spoil a little bit in the start, but anyway, when I started working with cloud, this was my, I would say, hate topic, but nowadays it's usually the one thing I talk about most with my customers. So we're going to talk about network, and we're going to focus a bit on how to troubleshoot and how to understand how the traffic is flowing and a little bit more on that part. So we give you a visualization of things rather than just technical depth.
Yeah, that's a topic that always come up with customers. So everyone stay tuned on that. And if you have any questions for Mattias, please go through the comments and ask his, although he's here, he's also going to be on YouTube answering the questions. Thanks for joining us today, man. And let's go to the next session on the show.
Enjoy the show.
Thank you.
Hi, everyone. My name is Mattias Lögdberg, and today we're going to talk about, well, nowadays, one of my favorite topics, but when I started my journey in the cloud, this was probably the thing I was running away from, networking. It's gone quite far during this year, so you have been with us for almost these 10 years or something that I've been doing this. You know that in the beginning, we didn't even have something called network. It was awesome, but nowadays we need to comply a little bit more with it, let's say. Let's just leave it with that. The session today is all about trying to explain what's going on, because we as developer architect often get the requirements to handle network, but we are not always aware of all the complex that goes around. And the idea behind this session is to give you an understanding of both changes during the development, but also understanding more about what's going on and why things are happening. Because in networking comes a lot of things that we don't really understand that well, which is all from DNS to routing to firewalls to everything. We won't go in depth of that, but we will explain where things is going, and hopefully we'll have a better troubleshooting situation in the future. And the whole thing today is going to go whiteboarding, because I really love whiteboard. So I'm only have one slide, which is whiteboard. And so let's get started. So this is my favorite tool. And if we're going to start about network, let's just start with the basic stuff we know. So we have this on-prem stuff. Let's just draw a little house over here, just to make it a little bit nice and sweet. And here we go. Look at my little house. Hope you feel welcome. Let's put the door up there. So this is our on-prem. This is where we come from. And we usually need some sort of access there. So let's just look at how that can be done, or usually is done, more or less. So in Azure then, we create some VNets, that's called. The first one we're going to create, which is, if we do the hub and spoke, this would be the hub. Or you probably do hub and spoke, and we will talk about hub and spoke in this case. So hub and spoke is a pattern for networking, and it's all about having one hub and a lot of spokes that you use later. So the hub, which is the first and most important one, is the one we're going to draw now. So let's just do that. And let's draw it up. And when I talk to people, because I learn this by talking to people, they usually create this first one with at least 3 subnets, or the ones I'm talking to do that. So I'm going to do the same. So let's do 3 subnets. These 3 subnets have very different usage. So the first one, or the one to the right, that's going to be the gateway. So in this, we're going to place a gateway. This is the one we're going to connect down to our on-premise. You usually talk about this as an express route. This could obviously be other ways as well, but let's just take an express route. Let's use that. So this is the initial connection between on-premise and cloud in this case. And in the next one, we're going to have our big old friend, the firewall. So this is the firewall, and that's going to be a very central piece, as you know, in network. There's also a few other components that is created as well. Something called a route table and a network security group. So network security is going to be shortened NSG, and route table is going to be shortened route table. We'll talk a little bit more about this in the future, but they always comes up on every subnet in the end. So we will have a, let's see, they were really small writing on that. Let's see if we do a little bit bigger route table. Wow. Okay. Let's do something for future for colors for this. Let's have a color. Let's do this yellow, and let's add a blue. NSG. So we have the blue one over here, and we have the yellow one over here. So let's do it like that, make it easier to see. So this is the kind of starting point. Next up is another one that we usually need. So now we're going to create our first spoke. But this is also necessary for us because we're going to create DNS place. So we need to have some sort of DNS management. And that's going to be created in another subnet, or a VNet first, and then another subnet. This is usually placed centralized in some way. And let's just do a 1, and let's do 3 here as well. We do a peering over here, which means that we connect our networks. So this is how the hub and spoke works. They pairs networks together. In this first subnet, I'm going to put in a private resolver. So a private resolver is a DNS resolver, in Azure, which then can be used very simple. The good thing about this is that it has one incoming for all endpoint for everything inside. Then we can route outbound, but by default, it will go directly to Azure DNS. And that has some good things with it. Oh, and let's just respell that one. It wasn't really pretty. Azure DNS. So this is the baseline for having a network up there. So we have, obviously, we have this route tables here as well, and we also have the NSGs. You could reuse the same, but I got a recommendation that you should do one for each network or subnet in this case. But, or not but, now we have the setup to get started. Now we want to start doing things. So usually, if you have ever heard of, I'm gonna use the concept landing zone. So landing zone is a concept of giving a development team similar an area to work with. It's usually a subscription with some subnets paired to our firewalls and stuff, or the hub in this case. Let's just write hub in here. Let's just write hub over here. So let's just do that. Let's create this. And we will do as before. We create this by 3, just to make it easier. And let's just do a 1 and a 2. And we do this peering again. Now we can start working with this. We can actually start routing traffic. But there are some things that we need to make sure when this is done, or we don't really make sure about it, but we actually make sure of it from network team usually does. Because it's creating these route tables and it's actually updating the route tables up here. So these route tables are updated when you add a landing zone. Oh, let's go back. There we go. Let's not have that there. Which means that it will get a route going down to this peering. So it actually will be a route from the gateway to the new landing zone. But network team will obviously, they want every traffic to go to firewall, so they will usually go ahead and in this route table, let's go ahead, they will do so landing zone 1, let's go landing zone 1 to firewall. So they will put up a rule in this route table that traffic has to go there. So when traffic comes from on-prem, it's going to go into this firewall. And if you're lucky and you get access, oh, hang on. So firewall is going to go there, and then if you're lucky, you're going to be able to go there. But that's the first thing that they do. They actually do this manual, but scripted, obviously, that they create this route. Same goes from landing zone back in. So the route table that is created over here also need an update, which means that 0, 0, 0, 0, /0 goes to the firewall. But it also needs to have that any traffic going to the hubnet also goes to the firewall. So there are rules they're doing because they want the traffic to go over there. They don't want you to be able to go over here without going through the firewall. So that's stuff that's going on. So let's just write up those NSGs and those route tables. So again, the route table in these are pointing anything going to 000, which is the default route, going to the firewall, or if you go to a specific thing in the hubnet, meaning the gateway, then you go to the firewall first. So all of these will have that. So all of these will have this in this landing zone 1. There we go. But we usually want to add some other stuff to this. We want to start developing things. That's what we want to do. So let's just say that we want to add some services to work with on this. So I'm going to add a, let's use screen, sounds good, a Cosmos DB, a database. It could be a Cosmos DB, it could be a SQL, doesn't really matter. I want to add a Cosmos DB to my landing zone, to my network, and I want it to be protected by our network. We then have two options. We have something called a service endpoint, and we have something called a private endpoint. For you who has been doing this for a while, you know that service endpoint has been there for quite some time, and that the private endpoints is fairly new. And there's big differences, or it's a bit, there are some major differences that we need to be aware of when picking these, because both of them will do protection, it will be granting access and so forth, but there will be a big difference in how they're doing this. So let's just say that we do a service endpoint for our Cosmos DB. So let's just use the service endpoints over here. This will then imply a few things. This network that we're talking about over here, this network will then be configured to be able to connect to Cosmos DB. So it will be a configuration on the subnet that is able to connect your Cosmos. You can then connect one or many Cosmos DBs in this case. Or let's just use another color. Let's use blue. So we can then connect this to this network. But we can connect many. So if there's more of these, we can use the same kind of configuration and do the same connection again, as long as they are Cosmos DBs. So this is a one-to-many. You can connect as many as you want, or not as many as you want. You will obviously have restrictions in IP numbers and so forth. But you can create a lot of them at least. We won't do that. We will keep it to that. Another thing is that when you do this, like I've done now, I've connected the Cosmos DB there. It will be initially open, or accessible rather. It will be initially be accessible to others. But you can, when you connect it, it will explicitly say, hey, you need to be in this network, or you can actually do a list of IPs that is allow list for IPs. So I can actually have my IP allow list over here, which I can add. So let's say I'm a developer, I want to get access from home. I can do this simple by just doing my IP on this allow list. I will have the same access as someone inside of the network in the landing zone, for instance. That's one problem, that you easily can open it up for anyone else. The other one is that it's still publicly accessible. So a big thing about this is that whenever you create something in Azure, you will have a public IP. You will have a DNS inside of your Azure up here. So it will actually get a DNS record here in Azure DNS. And it will have a public IP, which makes it discoverable. So this will always be discoverable during this approach. So service endpoints will always be discoverable. So we can write it over here, discoverable DNS public IP. And we also have this allow list. But the private endpoint works a bit different. We will go through it very soon. But that's how the service endpoint works. And as I said, we can add a bunch more in this as well. But let's do what we're here to do. We want to develop something, right? We want to develop a process. So we will actually want to create a Logic App standard in order to connect to this service. So we will create a Logic App standard. And as you all know, they are relying on the app service part, which means that we can connect it to a backbone VNet. So we can do this outbound VNet connection, which means that we can connect our Logic App back in. In this case, we can then go ahead and build a connector and do this get. Let's just build a small flow, and we have a get data. And we do something with the data, and processes are further on. When we hit this get data point, we will then route our, could be on the internet obviously, but let's just imagine it's going through a network. It will go like this. We'll go up here and it will be, oh, okay, I need my DNS record. Okay, it's over here because it's in the Azure DNS because this is the one we're connecting to. Traffic, on the other hand, traffic will go this way and securely go back to your service without going anything public. It will be secure, but the DNS part will go, could even be going like this. Zip. Okay, it's over here, and then traffic goes there. It's not very, very like dangerous, but it's something to be aware of. Our Logic app usually needs some sort of storage to be able to work, which means that in the beginning of this, we can just go ahead and connect to our storage like this, but we want to lock things down, right? So let's then introduce our, let's bring the arrow back because we can use it. So let's then use the private endpoint. So the private endpoint works a bit different. The private endpoint is something that you can put in a network like this. We'll put it in this subnet. And we'll then open a funnel into this storage. For storage account, we actually need 4 of them. Because as you might be aware of, there are different services on a storage account. We got blob, we got file, we got tables and queues that is needed by Logic App standard. So we need 4 of them. We can now get them to access through this network, which means that resources that are running inside of it, they can access it. But they can do that because we have a, let's just do again, a private DNS. So this is the other part of it. So we can create it in this subnet over here. We can connect it, but we also need to have an address for it, an IP. So we will create these private DNS for all of them. And we need one for each type. So for, let's go ahead and just write this down as well. So for storage accounts, we actually need 4 private DNS zones as well. And the beauty when we use a private resolver like this, and that has been connected as the DNS zone in our network, is that when we are running this, oh, we can do one more thing. Ooh, let's do the one more. Before we do that, we also want to make sure that we don't get an access like this. We want to remove that access. We can then say public access denied, disabled. And we actually lock down our storage account, and it's not possible to find it publicly. This gets away. So it's not possible to find. So if you would do a NS lookup or something on the same storage account that you to public accessible set it to disable, you will not be able to find it. The Cosmos DB you can still find, but the storage account is not being able to be found because it's using the private endpoint. So big thing is that it's not discoverable, and it can be it uses a private DNS. Another good thing is that we can use this VNet or subnet to a lot of these different services. So that's also good. So now, if we go ahead and just look how the DNS settings will go, from the Logic app, when we want to access this storage now, it's not public available. So we go like this, we go to this, and then we go into the private DNS. You get that data, and then you get the IP, and then it will go this secure way down to the storage. So this is a secure, nice way to get into the storage account. We can then, obviously, go ahead and do the same thing for the Logic app because we might not want that open as well. Which means that we can also, on this end, put it down like this. Obviously, we need to have a new private DNS over here. Let's just draw it like this to be able to put in the DNS for this Logic app standard. We now have a full lockdown situation, which means that we can't really go to the Logic app. We can't really go to the storage. We can detect the Cosmos. We can actually open the IPs to it. We could develop from it locally. So if we would do some code or testing locally, we could do that actually. But we can't really go to the Logic app and we can't go to the storage. So here comes the next problem, deployment. Because if you have done this with DevOps previously, they would have been doing that easily. If you could use the built-in agent, it will just run. But from this point, we put public access disabled and we use a private endpoint, we can't do that. We are locked out. That also means you as a developer, if you were working down here and you have your nice fancy computer, you will now need to go to a VPN like this in order to get in and be able to connect to your Logic app. Previously, you could have done that in the open, but from now you need to do that. You need to have a VPN and then you will go all the way down here. Then you can access stuff. And same goes for DevOps. So we then need to add something that we usually encounter. We encounter let's just write DevOps. So this DevOps has been really nice doing that. But in order to do this, and now I know that I'm not the best on this, but the things I've been working with has been scale sets. What's usually used is that someone is creating a scale set and connect an agent to that scale set. And when we have done that, we can then, through the firewall, allow traffic down to our Logic app. So we can then, with the agents running inside of this network, that's important, and having this firewall connected and open all the way down there to this private endpoint, then we can do deployment again. Just as we can connect to it via VPN and on-prem, or if you have that desktop connect VM in the network as well, that could also work. But you need to have something like that in order to get in. But that's an important thing to have coming up. And if we want to also add something like, getting data in, maybe we want that Logic app to be accessible to some other endpoint, we probably want to add something more. We probably want to add like an API management instance. So we then need to, again, add some subnet. Let's zoom in again so we don't get the big difference in size. So up here again, we then can create a new subnet or a VNet. And again, this is a new landing zone. Let's just do that. All of these is usually a new landing zone. Just to be clear, APM. And let's again divide this in a few because we need a few of these. And let's do this pairing. And the funny thing is here, all of these need to be routed through firewall. That's actually something they need to do when they put it up. As I said, it's scripted, so it's no big deal, but it's there. If we work for a big customer, we usually have APM in an internal mode. And if we deploy it like this inside of this subnet, we will then probably use an app gateway in front of this to be compliant with firewalls and then OWASP and that kind of stuff. And then we allow our traffic coming in this way. And then that gateway can connect to our APM, and then our APM can connect, if it's allowed, through the firewall, down here, through the firewall, down to this again. Same path as the other one, but going into your private endpoint and being able to expose an API to someone. And again, we can use key vaults and stuff. Usually we probably need like a key vault. And let's go. And we probably need like a private endpoint down here to get access keys. And we want to disable it again. And it will create yet another private DNS over here. Again, we'll create a bunch of stuff. But now we can route the traffic all the way to where we want it to be. The interesting part about this is, there's a lot of interesting part, but we need to configure this and we need to make sure. So usually, my encounter at least is both when you set this up for an APM instance, for instance, you need to make sure the traffic goes the right way, going down to your app gateway, going to your APM, and APM has a bunch of rules. Just be aware of that. Here's a bunch of NSG rules. We didn't go very far into the NSG, so let's do that now. Let's just add the NSG to this network, and then just add the route table as well, just for the sake of it. And go ahead. So in our NSG, we then need to allow a bunch of traffic. So we can do this. So the NSG is like a mini firewall. It will actually determine what can be accessed inside of this subnet. So in this subnet, which APM is in this case, we can then decide how traffic are allowed. So APM, for instance, is a PaaS service, which we need a bunch of these. So there is, as you can read up on it, there's a bunch of rules that is allowed. It needs to access SQL, it's storage, it's key vault, and a bunch of other services that you can use with a service tag. So you should use a service tag for these. As I said, this is well documented, so you don't need to remember this. Just look at their page or documentation when they do this, but that's something they can do. The NSG allows traffic in and out from it. And NSG can be very protective. So if you would say from the beginning that, let's say in this particular route over here, you can say at NSG, you can say deny all. Deny all. If you do that, nothing can connect to anything inside of the VNet or a subnet. So if we would add that into this subnet, nothing could connect to anything else. So they are very powerful and they're usually very restrictive in the beginning. So you really need to keep in mind of the NSGs and what rules they are. Most, I would say, have a rather okay approach. Usually not going to internet. Usually traffic needs to go to firewall, and so some services are easy to use. But as I said, APM requires a bunch of special NSG rules, just so you know. The last thing that I want to add in this case, since I have just a little bit time more, is the only thing we didn't really do, and I want just to poke it a little bit. So let's just say we have app insights for insights. So if you have a customer or you're a customer that is really keen on security, you can actually lock down your app insights as well. You can go ahead and say the whole monitor thing. It's called AMPLS. AMPLS. So you can require private endpoints on your app's insights, which means that traffic usually goes like this when it comes to Logic app going to an application insight. But if we use AMPLS, and it's usually actually on private endpoint going in here, or a private link, I would rather say, then you actually can connect your, let's use the blue again to make it more. So there we go. Then you can connect your application insight like this. Then you can, on your app insight, you can say that if queries are allowed outside, or if it's just ingestion that is allowed, or if both of them is required to do inside of your private endpoint network. So you can decide a bit like that. But that's really locking it down if you want to do that. A little bit, yeah, I think that's it. So in this case, as you can see, we have covered a bunch of stuff, and we got a small little map on this part. And hopefully you gain a bunch of understanding about the network routing and where to go. And as I said, a lot of the troubles that I get when setting things up, like an APM or a new Logic App standard, a new loading landing zone, it's a lot around DNS, it's a lot around firewall rules, and it's about understanding where things go. So keep in mind where your traffic is going, how is the traffic going. Like I said, if our Logic Apps need something, it's going to go up through the firewall, going to the private resolver, and either to our private DNS or up to the Azure DNS, depending on where your record is stored. And also, make sure to understand the difference between a service endpoint and a private endpoint. Service endpoint has been there for a while. It's nice. As I said, you can open your IP for your development, so forth. But there's also things like you need to be able to have you have your exposure, and maybe you don't want that. Maybe doesn't really matter for you, but it's important to know. I think my time went off. That was the alarm. Let's go going there. And I think I've done everything. And if you have any questions, just let me know. Just poke me outside. And besides that, I just want to say thank you very much. And I hope you enjoyed my session. And then you see my contacts there. So just reach out if you have any questions or you want to talk integration with networking or integration in all. And have a nice day. Cheers. Bye.
Thanks, Mattias. There's a really complex subject, but I think you managed to do it like step by step, which always make it easier to understand. Back to the show. Alex, do you want to introduce our next session?
Absolutely. Our next session will be hosted by Ankit Gupta. His session will be Mastering Azure Logic Apps, Renewing Lock Tokens and Peak Lock Service Bus Triggers. So Ankit Gupta is a cloud solution architect at Tata Consultancy Services, TCS, in Sydney. He leverages his extensive expertise in cloud consulting and integration services with a focus on platforms such as Microsoft Azure, AWS, and Google Cloud Platform, designing and delivering optimized cloud solutions. Ankit will show us how to build more resilient workflows in Azure Logic Apps by renewing lock tokens and peak lock service bus triggers for seamless messages processing.
Thank you. So let's add his presentation. And as always, just make sure that if you have any questions, add it to the comments, and we're going, either us or the presenters are going to work on that.
Hello, everyone. Welcome to my session on this Logic Apps Community Day. So today I'm going to speak about how we can master Azure Logic Apps and how we can use renew lock token action with the peak lock service bus trigger. So this is a brief introduction about myself. My name is Ankit Gupta, and I am working as a cloud solution architect with TCS. I am currently based in Sydney and have more than 18 years of experience in IT industry. I am a certified Microsoft Azure solution architect, and I am also a AWS certified and Google certified architect. So this is a quick overview of the Azure Service Bus to those who are new to Azure. So as you must be aware, Azure Service Bus is a fully managed messaging service from Microsoft that helps different applications and services communicate with each other. You can imagine it as a virtual post office where the messages are sent, stored, and then delivered to the right recipients. So when we receive messages from the Azure Service Bus, there are basically two modes. First is the receive and delete, and the second is the peak lock. The receive and delete, as its name suggests, when we use this mode, the subscriber application automatically mark the message as complete once it is received by the subscriber application. So that message is deleted from the queue of subscription. This mode is basically faster, but it is usually meant for the low value or non-business critical messages. The other mode is the peak lock mode. So in this mode, when the message is received, it is temporarily locked by a particular client's application or the subscriber. So the client's application usually marks the message as complete or abandon or defer or dead letter once it processes the message. This provides more control to the subscriber application so that they can process the message before acknowledging it. This mode is relatively slower, but it is mainly suitable for the business critical messages where you cannot afford to lose any single message from the service bus queue during processing. One limitation with this mode is the maximum lock which you can set on a queue is 5 minutes. And these locks must be renewed when the message processing takes more than 5 minutes. So this is one of the use case which I am going to demonstrate in today's session. So this is a live use case. We had encountered this issue or this problem recently in our project. So the use case is we need to process the batch messages from the Azure Service Bus through Azure Logic Apps. So the message inside a Service Bus queue is a batch message. Every batch message has multiple child messages which needs to be sent to downstream application. Every batch message takes more than 5 minutes to get processed. It also requires the sequential processing. So the second batch cannot be processed until the first batch is completely processed. Also, it is a business critical message, so we cannot use the service bus receive and delete mode. And it requires a private connectivity. So the application or the logic app that we had created, it is a private connected logic app. So we cannot use the logic app managed connectors in the logic app. So the solution that we came across was we had to use this renew lock action. So these are the steps that we performed in our logic app. So we used a recurrence trigger to schedule the logic app after every 10 minutes because every message was taking around 6 to 7 minutes to get processed. Then we read the message with the peak lock action from the Azure Service Bus. And then we iterate through the batch message and processed it. And then the main part, we use the renew lock action to extend the lock, ensuring the message is not lost or becomes available for the second run by another subscriber. I hope this problem statement is clear. Now I will be going into a demo. So here I'm using an Azure Service Bus queue. So this queue, you can see I have set the message lock duration as 5 minutes here. Now I will be sending couple of messages to this queue. So I am just sending 2 messages in this queue. So you can see I have sent 2 messages. Now there are 2 messages inside the queue. Now I will be going to my logic app. So this is a logic app which I have created in the standard plan. So this is logic app standard. I am going to the workflow now. So this is a demo workflow which I have created. Now I am going into the designer. So you can see this is a recurrence trigger. So the setting I have put is 10 minutes. So this logic app will be triggered every 10 minutes. Now this is, I am taking the messages from the demo service bus queue. Here I'm just checking the messages inside the service bus. If the messages are there in the service bus, I will continue with my process. Otherwise, I will terminate the logic app. Here I am just initializing one count variable to simulate a 5 minutes process in this logic app. So the actual use case that we had, it was taking around 5 minutes. So here I am simulating that 5 minutes processing. And within each iteration, I am renewing the lock on this message queue. So you can see that this is the main part. So here I'm using the renew lock action. And I am using the lock token to renew the message. And then I am marking the message as complete with the lock token. So here this logic app will be triggered now because we had pushed 2 messages in the service bus. So you can see the logic app has triggered and it is running. Now let me go into the logic app again. So here the logic app has triggered. It has got the message from the service bus, and it is now doing a iteration for 5 minutes. So this process will take around 5 minutes. So if I fast forward it, see, the process has completed. It took around 5 minutes, 5 seconds. And then I have completed the message in the queue. And this message has now been processed from the queue. And now this logic app will wait for 5 minutes, and then in the second run, it will process another message from the queue. So this was a short demo on this one on this use case that I had described. Thank you. Thanks for attending this session. If you have any questions, please ask me. I will be around. And thank you so much.
Okay, so that was the session from Ankit, right? The making sure that you can work with your lock token, especially for long-running transactions, is something that is quite important. So much so that one of the templates that we created for Logic Apps standard was a pick lock with the token renewal. So if you wanted to know a little bit more about that, or we wanted to see an example similar to what Ankit did here, take a look at the new templates that are available now on Logic Apps standard, and you're going to find one of them there with pick lock with token renewal. So we can simplify that process for you. We have another guest here in the studio. So let me bring Cameron McKay to the stage because he's going to be our next speaker. Hey, Cameron.
Hey, everybody.
Hey, man. Really good to have you here. So you're making my life easier because then I don't have to talk about you or about your session. You're going to do that for us. So can you give a little bit of intro about you and the session that we're going to see soon?
Yeah, 100%. Thanks, Wagner. Yeah, so hey, everybody. So my name is Cameron McKay. I'm a manager here at M&P. I do a lot of integration work with a lot of clients, global clients around the world. My main focus, something that's really dear to me, is defensive programming and just making sure that security is at the forefront of everything we do. So through the whole SDLC, the session that we're going to look at today, the one that I'm going to be presenting, is my background is in a lot of pro code, and I've kind of worked into integrations and been working in that space for a little while, and making sure that, with Logic Apps, it's really nice that we can have that pro code and low code experience. And we saw earlier with Igor where he was showing us the inline code pieces. So I'm going to touch on that a little bit and show some of the .NET custom code and how we can actually use that in API and live solutions in Logic Apps.
Oh, that's awesome. Thank you. And the camera was our last or previous aviator of the month, right?
Yeah, that was fantastic. Thank you for the honor. It was great.
Thanks for the contributions, man. It's really helpful. Helps to keep the community growing. Okay, so let's to the show, and as the usual, camera is going to be on YouTube to answer all your questions, and we're going to be highlighting the ones that are might be interesting for everyone here.
Okay, so I'm really excited to be speaking to you today at Logic Apps Community Day on this topic of transitioning from pro to low code with Azure Logic Apps. Now, this is a topic that's really important that I find, and it's something that I feel that pro code developers could really adopt and improve their overall tool set and their architecture and solutions overall if they were to adopt some low code. I just want to dispel any ideas about how I'm saying that pro code developers should become low code developers. What I'm really saying is that pro code developers could benefit a lot from taking some of the advantages of low code and integrating them into their everyday practices. And so the agenda for today's session, we're going to spend a few minutes just talking about quick introduction, the goals of today's session. Then we'll jump into, how can you as a pro code developer fit into this new or advancing low code landscape. Then we'll talk about Azure Logic Apps as our low code tool and how we can take, things that we already know as pro code developers, implement them in low code using Logic Apps. And then we'll jump into some demos. We'll spend most of the time there showing you how you can actually use Azure Logic Apps to implement a lot of the pro code patterns that you already know today and leverage them directly in a tool like Azure Logic Apps. And then we'll have some final thoughts at the end just to kind of wrap everything all up. So who am I? So my name is McKay. I've been a software developer for the past 10, 11 years. I mainly do web development. I am a pro code developer at heart. I've written and developed a lot of enterprise scale web technologies or web applications, done a lot of cloud native Azure development, and I'm a strong proponent, an advocate for defensive programming. So security is at the forefront, OWASP top 10, all those fun things are things that, we should all be thinking of as a pro code developer and also a low code developer, because all these things can leak into our solutions, make sure that security is at the forefront of everything we do. And so there's two goals that I have for you today. One is that I'm hoping that you will understand at the end of this presentation and throughout how you as a pro code developer can actually take the skills that you know every day and apply them in a low code situation or environment. The second being that I'm hoping that you can actually take the things away from this presentation through the demos and take it and implement things that you're learning, take your pro code knowledge and implement that in a low code environment. So let's talk a bit about, what is the trend? Like, what are we talking about when we think of low code and pro code? But really, there's this item that kind of came about where, every software solution that we see today is pretty much a software as a service, a SaaS solution that exists. Things like Microsoft Teams, Outlook, these all exist as a standalone SaaS solution. And so there was a need. So typically we would develop with pro code and we would build these solutions where we'd be integrating, doing HTTP calls, like putting all these communications together to do integrations. And so the idea came around that, well, we can have citizen developers, we can have the business actually develop using low code and build things that allow us to implement these solutions together. The business already knows what they need to do, and so they can integrate and move data around with those systems. And so where does this leave us as pro code developers? How do we fit into this landscape? We're used to writing, C# or .NET code. How can we actually live in this low code environment and also build things in pro code? So let's talk a bit about citizen developers and pro code developers. Where do we fall in this landscape? So in my opinion, citizen developers should be looking at building things using personal automations, so things just for themselves. They can build things and share them with their colleagues, so some close friends or some very close people within their organization, get some optimizations and efficiency there. They should be looking at things that are very low in complexity, so things that don't require a lot of manipulation. There's not a lot of business logic, very low risk items. That's where I feel citizen developers really shine, building those automations in low code or any platform, and basically integrating with those SaaS solutions and building in that way. So us, as pro code developers, where can we really shine? Well, we shine when we're thinking about not just a single person or a few people. We want to look at the entire enterprises. We want to look at entire departments. So we want to build things that will be used and will impact the larger organization. And we don't just want to look at things that are very low in complexity. We can definitely build those. However, the more complex, the harder, the more risk associated with building those automations and integrating with those SaaS platforms, that's when we should really be pulling in pro code developers. So if there's a lot of risk, say you're talking about finances, accounting, there's a lot of security involved, that's when you really want to involve pro code developers. And so if you think about, why do we actually have citizen developers? Why do we have low code? Why are we using these things? Well, as anybody who's existed in this industry for any length of time knows, the cost of writing custom apps is expensive. And through the adoption of citizen developers and low code, we could potentially remove some of these things. If the time and the cost of all those things kind of adds up. So if we can integrate low code into this, potentially we can improve our ability to compete with our competitors and deliver solutions quicker and for less cost. So to drive this point home, let's look at a few things that you traditionally do in pro code versus low code. So let's talk about HTTP client. This is a very common thing we implement in a lot of our applications, a lot of our integrations. In a pro code environment, you have to wrap the HTTP client library, you have to test it, you have to configure it. In low code, you literally just add the HTTP action and then off you go to the races. Look at another very common one. If we're sending emails through applications, we have to use the SMTP client. We have to wrap it, we have to unit test it, we have to configure it. If we're using low code, it's literally just there as an action available to us to leverage out of the box. And I could go on and on about various clients, Azure Storage Client, Azure Key Vault Client. There's a lot of these out there, and you have to follow the same practice in pro code, whereas in low code, you can just use it directly out of the box. So what if you, as a pro code developer, could leverage the skills that you already know in a low code environment? What if you could focus your efforts on design and architecture and integrate and create a hybrid of pro and low code together? What if you could take all that time saved and move it to something that would make your solutions more maintainable and reliable by adding additional testing and documentation? What if you, as a pro code developer, could deliver business value very quickly through pre-built connectors available to you in low code? Well, I'm here to tell you that Azure Logic Apps is available and can provide you all of those benefits. So let's talk a bit about Azure Logic Apps as our low code solution. So Logic Apps comes in two forms. We have consumption and standard. When we talk about these two various types, the way I like to look at it is consumption is a slice of the pizza and standard is the full pizza. So there's a lot of different functionality that's available to you in standard. Each of those slices gives you different functionality, different features that are available to you. And with consumption, you're kind of getting one slice out of that and you're able to utilize it. So let's just talk about standard. And the reason we'll talk about standard is because it allows us to have dedicated compute, which is important to us from a security standpoint. So if you have data security, you're going to want to make sure it's going through a virtual network. Make sure that you're using your own dedicated infrastructure. Standard is predictable in terms of the pricing of it. We're going to run on an app service plan, and therefore we can basically state that we're going to spend X dollars or very close to X dollars every month by running our Logic app in Azure. And the one key one that I think really drives home for pro code developers is that in standard Logic apps, you can have many workflows. And the reason I'm saying this is important because we're very used to following single responsibility principle as pro code developers, building different functions and reusing code. And standard is what allows us to do that through the use of many workflows. You don't get that functionality with consumption. And so to drive this home, why does standard hit the mark? Why do we want to use this? Ability to have it on its own virtual network gives us that security, which we really like. Predictable pricing is huge. That multiple workflows is also something that is really important for us as pro-code developers. And then finally, the one thing that we're really here to talk about is this idea of hybrid pro and low code. And that's something that you can only do in standard. So if we look at kind of your basic logic app infrastructure, so if we're talking about Azure and how this all works and things that fit together, you have your logic app at in the center. You're going to have a storage account. You're going to have logging with your app insights. You want to put your secrets in Key Vault, and then you're going to have your app service plan running underneath. So we talk about our development stack. So we're typically used to developing in Visual Studio Code, and we deploy into Microsoft Azure. We're going to use GitHub, GitHub Actions, Azure DevOps pipelines for deployments. And then our technology we're going to be writing our code in is Microsoft.NET and C#. So we can write any web solution, a console, desktop app solution, you name it, using this stack. This is what we're used to as pro-code developers. Well, I'm here to tell you that it is not going to change very much if you move to a pro and low-code development stack. The only thing that changes is you're going to be using VS Code, something you're used to. You're going to have Azure Logic Apps as your low-code solution, and you can still write code using JavaScript and C#. You can still use Microsoft Azure as your deployment or hosting platform for infrastructure, and then you're still going to use GitHub Actions or Azure DevOps pipelines for deployment. So with all that said, let's jump right into a few demos. So here I'm going to show you some of the various use cases of how you can take things you already know from a pro code perspective and use them in low code. And so before we start here, for anybody who's brand new in a pro code mindset and you're coming into a low code environment, just want to tell you it's very simple and very easy to get started. You can create your first logic app within seconds, and all you really need to know is this idea of there's going to be something that triggers something. In a lot of the examples I'll be showing you, they're going to be HTTP triggers. So you can call it using any HTTP verb and have your workflow run as a result. You're going to have some kind of actions running underneath. And then because we're using an HTTP endpoint, we're going to have HTTP responses. So very similar to kind of a web kind of API that we're used to using as pro code developers. And so let's jump right into a few demos. So our first demo here is going to show you something you're very familiar with. And so we're used to writing JavaScript C# code. So we have here our intro trigger, basically saying, when we receive a request. This one you can use in all of your workflows. And here we have a response that I was telling you previously in that other slide. So this will respond with a 200 HTTP status code. And the cool part that I want to show you in the middle here is you can do inline code as actions. So this here is an action available to you, allows us to execute JavaScript code. And so you can write whatever JavaScript code you need to in here. So if you're coming from a JavaScript background, this is available to you out of the box. You can just throw this in and you can do whatever you need to with it. And so just to kind of give you an idea of what's happening here. So here we're accepting a payload of an array of integers. We're taking that payload, we're pushing it into our inline code action. We're writing JavaScript. We're writing using the reduce function in JavaScript to sum up all of those integers in that array, and then we're returning the sum. So this will look very familiar to developers. Then at the end here, we're responding back to the caller with a 200 and the result of our sum. So something very familiar, something you're used to as a pro code developer. You're able to kind of see parallels here, exactly how you can leverage low code and pro code together. So going back to our slides, I want to talk a bit about scopes. And the reason I want to talk about scopes is because as pro code developers, it's really important for us to create and build things using SRP or using solid principles, single responsibility principle being the one that I want to focus on right now. We want to make sure that every scope, and so scope is a type of action that you can leverage, every scope has a single function. And if you do that, you can organize your low code into very modular, very reusable, and very readable function points. And so this should parallel things exactly to how you would think about functions in C#, or even regions in C#. You're putting all the things that do specific functionality, do one thing, into a scope. And I kind of like thinking of them as they're your best friend. Don't just throw a bunch of actions into your low code. Use scopes. They're going to make your life easier, and they're going to make the life of the next person looking at your solution much easier. And so we're going to look at one pattern that we're very familiar with in pro code, that being for error handling, that being the try catch finally pattern. And so look at what that would look like in low code. And the way we implement this is through scopes. And so you can see here, we have our trigger again, when we're accepting a request. And here we have 3 new actions that we haven't seen before. We have 3 different scopes available to us, and we've named these, try, catch, and finally. And so whenever I start building something, a new workflow in low code, I'm always going to come here, and I'm always going to put these 3 things in. And the way this works is just like you would in pro code. You put all of your functionality inside of your try, you put your error handling case inside of your catch, and then finally is going to be your cleanup. And so the way this is set up is we have our scope for try. If we click into our catch, we can go under settings, and we can see that catch is only going to execute if try fails, and finally is only going to execute if catch succeeds, times out, skips, fails. So it will always execute like you'd expect it would in a pro code environment. And you see if we expand these underneath, this is doing some kind of HTTP call. If that fails, it's going to come in here, and we're going to fail gracefully. And finally, we're going to do some cleanup here under our finally action. So the last demo I want to show you, and it's something that we've built recently, is we actually built an API using Logic Apps. So you could build these APIs using pro code, using Azure Functions, using .NET Web API, MVC, a lot of ways you could build these things. And so in our case, we built this API leveraging Logic Apps, and it was built as a stateless API, which allowed it to handle a lot of throughput that was coming at it. And this API was able to handle millions upon millions of requests, no problem. It scaled very well, and it essentially was a create endpoint, so a post endpoint, where it was taking some form data and then pushing that into a data store. So I want to walk you through this API, because I want to show you some of the practices and some of the things available to you, and how you can actually hybrid and develop in both low code and pro code. So one of the first things I want to show you is input validation. And so input validation is something that's really important, especially if we're talking about security. And the reason for that is, if you ever attend a security conference or a seminar, the first thing, and the one thing you're going to hear them talk about a lot is never trust untrusted data. So anything coming at you from a form, from anything, you cannot trust it. You need to do something to it to make sure that there's nothing bad going to happen once you start actually executing, the real reason that you're calling that API or that endpoint is executing. So one mechanism that's available to us out of the box with low code that could take some effort to do in pro code is directly on our request action here. You can actually pop in a JSON schema. And so this follows all the conventions that you'd expect of JSON schema. Here we're validating, whether it's a string, we're validating things like what's the minimum and maximum length, whether it's a required property or not. And so there's a lot of information here that we're capturing, required fields. And so, anything you can imagine with JSON schema, you can validate here as well, and it will respond back with a 400 bad request. So that's really powerful and really useful. You can see we started with the try catch finally pattern here as well. Like I was saying, anytime I start doing development in low code, these 3 scopes go in before any other actions go in, and they're all configured as soon as they go in. So let's jump into this try. So you can see that we're using SRP here. We have 3 scopes underneath. The first scope is doing input validation very clearly. Then we are leveraging reCAPTCHA to prevent bots from just hammering this endpoint. And then we're saving something to a data store. So you can see it's very separated in terms of the responsibility of what's happening at each step. And if we jump into our input validation here, we have this new action available to us, which is call a local function from this logic app. And if we jump in here, you can see it's calling this function named input validation, and it's actually passing the input into here. And what's actually happening, if we click over to our Solution Explorer, is we created a logic app workspace project that allows us to do custom code. And so over here, we have a C# class that is an Azure function, and it essentially will run locally on the same instance as our logic app, and you can actually call this pro code directly from our low code solution. So what's happening in here, like I was saying, don't trust untrusted data. We're not doing that here because we actually wrote a C# function that is leveraging the HTML sanitizer framework available to us, recommended by OWASP, the OWASP Foundation, and we're doing some sanitization. So we're sanitizing whatever input came to us because we can't trust it. And then we're also doing some whitelisting in terms of the object. So submission, the input, we have a class defined below here with all these different properties. So once we have whitelisted this object, we know that nobody can do remote code execution, and then we can serialize it back and then return it back to the caller. So the idea with this is that we can leverage the best of pro code, which is doing the sanitization, or one of the examples of best pro code where we can use the sanitization, leverage libraries that aren't normally available in low code, do this kind of logic that isn't normally available in low code, and kind of combine them into one best of all solution. So we know that after we've reached this endpoint, or once we've reached this action and what comes out with that JSON, it's been sanitized. We can trust it. We can trust there's no injection happening. There's no bad nefarious things going on that we need to handle. And so now that we know that that's there, we can also leverage this really handy action, which is parse JSON. And just like the one I was showing you up there, you can pass in a JSON schema and you can validate all the information that's coming out of here as well, which is really powerful. And so we also have handling. So if either of these actions fail, we are going to respond with a bad request. So we have our response here and responding with a 400, our typical status code for bad request. Another really powerful ability with logic apps is you can actually short circuit the execution. So when you're writing pro code, you often have an if statement where you perform some kind of calculation, and then once you have the answer, instead of going through the full execution of your function, you can return early. But we can return early in low code as well. And we can do that using this terminate action. So this will terminate and fail the workflow, and we will make sure that we're not going to execute anything below here as well. So this is really powerful since we can short circuit and execute early or return early and not have to worry about all the processing below. We know that we're going to stop processing here because everything it's invalid. We shouldn't be processing further. And so we can move forward knowing everything is good after this step. So an example of a few control mechanisms that are available to you in low code. You can also implement these in pro code using the same Azure function piece that I was showing you earlier and call it from there as well. Just to give you an idea. So here we have an HTTP action, talking about HTTP client and wrapping that. Here, instead of doing that, we can actually just make calls directly using this action. We don't have to worry about configuration or testing or anything there. We know that this HTTP client has been implemented and it works. We can take the information back there and we can actually implement it and use it below. So here we have a condition, a series of if statements. This isn't pretty to look at, but it kind of facilitates the point to show you, what you can actually do. If you want to add conditionals, you can. Basically, we're checking the response from reCAPTCHA and then handling all the different types that come back from it. So you could also do this as a switch or an if statements in pro code as well and leverage that in the back end if you so chose. And just to complete this example, once we reach the end, we have the ability to save to a data store, and you can see We're leveraging the compose action. So this one's really powerful for doing printing things back, seeing the state of your running application. If you're doing a stateful workflow, or in my case, I'm doing a calculation, I want to see the date in the format of year, month, day, hour, minute, second. And then we are leveraging the SQL Server connector to allow us to insert information. So now we don't have to worry about configuring this so it can handle a lot of data or a lot of information. We know the SQL Server connector will work. And at the end here, you can see we're responding with success because everything went through. And here, if any errors happen, it's going to terminate with a 500. And you can see throughout this whole thing, the organization, the naming, has all been set so that we're able to easily see and understand what's happening. So going back to my slides here at the end, just to provide some final thoughts. As you can see, pro code and low code as a hybrid is definitely possible, and there's a lot of gains from doing that. And here's a few numbers on the screen: 50, 10, 70. And really what we're saying, what's been said is that by Red Hat in 2018, low code platforms reduced app development time by 50%. True or not, it's 6 years ago. So it's very possible that this could happen, and it could reduce your development time by 50% if you were to leverage a hybrid development pattern. Forrester in 2018, said that it could speed up application development by a factor of 10. So there's a lot of advantage here to actually using a hybrid of pro and low code in your solutions. And then 70% of new businesses will use low code by 2025. So that's a year away. That was Gartner in 2021. So it really makes sense to start using low code as part of your solutions. And so to kind of wrap things up here, I hope that throughout this presentation and by walking through it with me, if you're a pro code developer or even a low code developer, you understand now, how you can actually take the information as a pro code developer and leverage it as a low code developer, or as leverage low code as part of your solutions. And then finally, if you wanted to, jump into it tomorrow or even right after this and start implementing things in low code, you would have that option available to you. So if you want to contact me, my email is here. Feel free to connect with me on LinkedIn. And thank you, everybody, for allowing me to present this to you. And I really hope you found it valuable, and hope you have a great Logic Apps community day.
Thank you very much, Cameron. It was a really interesting session. I think it's low code and pro code together is really the way to go. It's like taking advantage of each one of those items. So for the next session, we have Angad Soni, and he's going to be showing a use case, right? So predictive maintenance for manufacturing equipment. So Angad is a vice president and chief architect of Longview Systems and brings his extensive expertise in data analytics, cloud technologies, and digital transformations to lead innovations initiatives across diverse sectors. So what he's going to be showing us today is how to implement a predictive maintenance system for manufacturing equipment to prevent downtime by generating and scheduling maintenance tasks, all of that using AIS components. So let's go and add his presentation.
Hi, welcome everyone. My name is Angad, and today we will be starting a Logic App session around building intelligent solutions, specifically looking at automating predictive maintenance with real-time IoT data and how Logic Apps can really help us orchestrate and set up the entire process from an end-to-end standpoint. Before we jump right into it, a quick introduction of myself. My name's Angad. I work at Longview. I'm the VP and Chief Architect for our data, AI, and business applications practice. I'm not going to read everything on the screen. The biggest thing to take away is I'm an overall data nerd. So I've been doing Logic Apps and been in this data and predictive space for quite some time now. So I'm really excited to walk through the session today. One of the reasons why I've decided to move in this is when we really think about where we're competing as an organization and as individuals, we're really looking at, for today specifically, the manufacturing side, right? The reason we're really looking at manufacturing, if we think about the overall market, we're looking at a $3.8 trillion market. So to be able to capture a portion of that market using some of these predictive models as well as layering in first-party applications like Logic Apps, can really help us orchestrate and deliver robust solutions for organizations and for our customers. And when we think about what I'm going to present today, we really are going to go through the Predictive Service Hub. What that really is, it's what we're calling a Predictive Service Hub, is an amalgamation of different Azure technologies, right? So we're going to look at Logic Apps, we're going to look at an IoT hub, we're going to look at an event hub, we're going to look at some form of cognitive services to help with the prediction side, we're going to look at some reporting. So the whole idea being it's a suite of Azure products that allows us to create this Predictive Service Hub that we can then execute against. So what is predictive maintenance? I think we've all heard about around proactive maintenance. I mean, if you've ever had a car or taken your car in, you know the reason you're taking it into maintenance is to be proactive. Sometimes it really doesn't need it, but the lights are on, so you really want to make sure that you're going in and updating that. When we think about it from a manufacturing standpoint, one of the main reasons for having proactive maintenance is to reduce downtime. But if the machine isn't ready to be reduced down and isn't really ready for maintenance, you are just creating additional downtime for no real reason. So what's causing that really impacts your overall execution strategy at the floor level from a maintenance standpoint, and it also increases your overall costs at the end of the day. So one of the benefits about predictive maintenance is that because organizations have spent so much time in proactive maintenance, and we know the history of how machines deteriorate over time, we can really use that data to effectively communicate with the end user or the end consumer when is the best time for the maintenance of this specific machine. So when we think about what a definition of predictive maintenance is, it's really that. It's using data and analytics to predict the most likely outcome of a failure and making sure that we approach that right before the failure is about to happen. So the way that we're going to use that is we're going to use advanced algorithms, predictive maintenance. We'll be using some machine learning data. We'll be using cognitive services. The information is really going to come from sensors. So in this case, it's going to be IoT devices, whether those devices provide temperature reading, sound reading, any other gauge reading that we require to detect the anomalies and then try to predict when a failure is about to occur. So one of some of the core benefits, as I mentioned earlier, it really does reduce downtime. We do live in a 24/7 world now, so if we can really work to reduce downtime on one of these large complex machines, then it really would, one, improve the overall organization's profitability, as well as allow them to have inventory at the right location at the right time, and lowers maintenance costs, because now you're not going in on fixed intervals every single time, going in and maintaining it, even if the equipment isn't ready for maintenance. So really reducing that overall cost. The other thing is you now have more predictability on when it's going to be maintained. So you have a better understanding of when to schedule your maintenance as well. So better predictability allows you to lower that maintenance cost. It improves equipment reliability because now you're actually monitoring it with appropriate information rather than going with gut. It's most likely going to extend the equipment life. In certain cases, it doesn't because you're noticing that the equipment deteriorates faster, so it allows you to even provide additional quality assurances on the product, and overall improves safety. We're making sure that we're not pushing the machine until the point of accident or failure, and oftentimes pushing it to the point of failure causes more deterioration and accidents to occur than if we would have just stepped in and done a proactive maintenance rather than predictive. So Logic Apps. We all really know what Logic Apps are, but my quick and dirty, simple definition of it is one of the best workflow orchestration tools that exists out there, with a plethora of different connectors that allows you to really build complex implementation and integration solutions with intelligence. So when we think about like how to use Logic Apps in a predictive model, what we're really going to do is we're going to use Logic Apps to orchestrate our overall workflow. So as data is coming in from the sensors and lands in the IoT or event hub, that's when Logic Apps is listening. It grabs the information, pushes it down the appropriate workflow depending on certain criteria as we're going to read through that message, right? Is it, what type of device is it? What type of sensor information is it? Is it a valid device? Is the device even being registered? Is it junk data? Is it valid data? So on and so forth. So really starting to build our orchestration model on top of that. So when we start building that orchestration model, one of the things we're going to run into real quickly is that we need to write some code. We need to be able to understand what these events are. We need to be able to define these events. We need to provide some structure and the data on top of that. And that's really where we end up using Azure Functions. Really like to work in the microservices ecosystems, allowing us to build these microservice functions, then allows other aspects of the business also touch in on that. So if someone is validating or testing a new IoT device but don't want to push it all the way through the Azure Event Hub that exists, they can invoke that function right away, see how that works within that ecosystem just in parallel. Again, we are using predictive maintenance, so we are going to be using a machine learning model. The model is really all around finding anomalies in the data sets and also looking at historical deterioration as well as overall runtime for the machine. So when we build most of these solutions, we really like to think of it with some guiding principles. The reason for these guiding principles is that it allows me to ground myself in the decisions I'm going to make as I design the solution and design the architecture. You know, some of these are fairly simple, which is want to be cloud first, we want to be scalable, we want to be agile. But ones that are really important to me is to start small and iterate quick, right? So where I've fallen apart is really trying to overcomplicate the solution or trying to build out the exact solution beforehand. Whereas I start with really nimble aspects of it. Like step one would be, can I connect to the Event Hub? Great. Can I connect the Event Hub to Logic Apps? Awesome. Now we can start adding some more complexity, some more intelligence, some more insight, because it allows the QA process to also be a lot easier. So why did we come up with this? So the challenges that we're faced is manufacturing companies often face related maintenance maintenance issues on their production equipment, right? Unexpected breakdown, high equipment costs, things that we've already covered. So the solution we implemented was Logic Apps in this case. They were already cloud first with Azure. The data was already being sent over to an Event Hub, but nothing was happening post that. So we came in and built out the overall workflow, the orchestration model, as well as an end state report that allowed end users to actually really communicate with the data to understand what it actually meant. You know, that really allowed us to improve the overall uptime and reduce cost by over 30%, which was a great feature for that. Provide a little bit of insight into the overall architecture that we used, really simplified architecture. You know, we've got some IoT devices, there's a device simulator that we use, it lands into the IoT hub, and all of the lines and everything else are orchestrated all by Logic Apps. So once we have some rules on top of the stream analytics, we've now replaced that. So it's a little bit old in that case. It goes directly into a service bus, and from there it can take the Logic App route. It runs through a field service module that we've implemented. It goes and validates devices, and you can see a lot of the information that's taking place in there. So really a lot of where the insight and intelligence is coming in is around our threshold and rules, and then around where we need to orchestrate and send that information. Again, the overview of another case study is around production equipment that have been facing maintenance challenges. So the issue was that every time they did maintenance, they found that they had to come back and redo maintenance because they weren't doing it at the right time. No matter how proactive that they tried to be, no matter how many times they tried to readjust the schedule, it just wasn't making sense. So when we came in and we built this model out, one of the things that we noticed was that they were actually fixing the wrong part of the machine. And that's why it continued to break down until they eventually made it to the right one. So just having the data and being able to analyze that data alone provided a lot of insight before even getting into any of the AI or machine learning or intelligence aspects of it. How are we really implementing this solution, right? There's three main layers to this. Whereas the data integration layer, ingestion layer, pardon me, we need to go and grab the data from somewhere, wherever that exists, whether that's landing in an Event Hub, whether that's landing in some other location, we want to go grab that. And then we want to provide some form of model training. So in this case, we use cognitive service machine learning within Azure, and we built an anomaly detection model. And that really was looking for anomalies in data sets, whether that be failure alerts or something else. And then that's where the alerting rules come in, right? So once the model predicts something, whatever that prediction is, how do we want to deal with that prediction? Do we want it to go ahead and create a service ticket so that someone can go ahead and schedule a maintenance? Does it want to alert someone so they can review the data before they create a service ticket? So it gives the end consumer a lot of options in terms of where they want to use this information, how they intend to use this information. And really the conclusion of all of this is that what we're trying to do is we're trying to build pragmatic solutions that are going to drive value today. AI has become such a buzzword around everything, but what I wanted to do was showcase how, without even thinking about going into the conversational space about AI, thinking about how an overall really well-defined workflow, an orchestration workflow using a technology like Logic Apps and ingesting data from IoT devices, adding other components like Azure Functions, adding intelligence like cognitive services, can provide a really, really robust solution. And for me, this is really a funny cartoon because it really allows us to become that manager of business results, right? We've all heard everyone talking about how great things can be or what machine learning can do, what AI can do. This is a really practical implementation where you may not be in, let's say, a manufacturing ecosystem, but you're going to have certain devices, and the device could be anything. Realistically, it could be your social media feeds, it could be the number of people walking through your store, your location, it could be video feeds. Whatever that happens, you can really adjust this solution to extend and provide value to whichever aspect of your business you're looking at with those real-time capabilities, providing some intelligence on top of that. With that, I'm going to conclude this session. Really happy that I got the opportunity to speak with everyone. Again, my name is Angad. It's great to meet you all.
All righty. Thank you so much, Angad, for all of your presentation. We have another exciting presentation from a familiar face that I'm sure a lot of you know, Sandro Pereira. So Sandro is going to be talking to us about Logic Apps, everything you need to know about error handling. Sandro is the head of integration at DevScope, so he doesn't need introductions, a prolific blogger and public speaker. He's a longstanding Microsoft Azure MVP and well-recognized community leader. He's going to share with us his vast field experience, tell us everything we need to know about creating good error handling patterns for our Logic Apps. So with that, I will give it to Sandro to introduce himself because he doesn't need any introductions.
You already told everything. Thanks you for inviting me again and accept my session. It's a pleasure to be here once again at this amazing event. I hope you like the session. That's it. So
please
go forward.
Yeah. Thanks for joining live, Sandro, to say hi. Like the people always like to see you. And I'm sounding like a broken record, but if you have any questions, put it on the chat, and between us and Sandro, we're going to answer. See you all later.
My name is Sandro Pereira, and I'm here once again on the Logic App Community Day talking about this time error handling. So everything that you need to know about error handling, both in Logic App Standard and Consumption. I'm the head of integration at DevScope. I'm a long time an Azure MVP. I think this year is the 14th time that I'm on the program, and it's a pleasure to be here. You have my contact information there, my email, my LinkedIn, my blog, so feel free to reach me out if you have any questions regarding to these topics or any kind of topics related with enterprise integration. I'm also an instructor of trainings about Azure integration and BizTalk. So if you have a need for that, also feel free to talk me and contact me for that. Now, one thing is clear on enterprise integration is that at some point we will have a fail in our process. So they will fail, okay? That's 100% sure. But at some point in time, they will fail, okay? And I normally say that failure is good. We need to learn from failures to keep upgrading and improve our process. So it's a step to the success of our integrations to be more robust and effective, okay? One of the things that is important to know is how to handle these exceptions, okay? How to control these exceptions inside our workflows in order to guarantee that they are robust and we can recover from that, okay? There are many ways to do that. So if we do an analysis with the C# code, and I know that most of our developers, we came from this programming language background, we know very well, we will have a try, a catch, and sometimes a try catch finally, and that's quite easy to accomplish in C# language or in other type of language, okay? We want to have the same capabilities inside our workflows, inside our Logic Apps. And this is what this session is all about, okay? So again, there are many ways to accomplish that, but basically, the way that we implement the try-catch finally, or a try-catch symbol, is with scopes, okay? We create a scope, let's call it our try scope. We put all the actions inside, can be straight actions, or it can be conditions inside, and so on and so forth. And then just after that scope, we create another scope, and let's call it a cat scope. And we need to define the run after settings. And for that, we have to say that if something fail, or if there is a timeout on the try scope, that is just the action above, then this action needs to be executed, okay? So if some problem happens inside the try, the catch will be triggered and be executed, all the actions that are inside, okay? So with these two conjugations of scope, we have a try catch. Now, if you want to implement a finally, just below the cat scope, we create a finally scope. And then once again, we have to configure the run after settings of that scope and basically select everything. If something happens on the catch, if it's success, the catch, we need to execute the final, because the final always runs. If something fails on the catch, once again, the finally only runs. So you have to select all of these in order to say, no matter what happens with the catch, I'm going to be executed, even if it's skipped, okay? If it's skipped, normally that means that the try scope was executed successful. So all of these has to be selected. And with these three conjugation of scopes, we have a try-catch or try-catch finally implementation inside our logic apps. No matter if it's consumption or standard, it's the same. We are seeing here the still the old designer, but when we go to the examples and the demos, you will see that with the new designer is the same. Okay, it's just a matter of presentation. Okay, so with these three conjugations, we have a try-catch or a try-catch finally. Now, as I say, there are many options also inside Logic App, not only this one, okay? So each action that we add to our workflow, they have a run after settings that by default is if the previous actions is successful, okay? If the previous action run successful, then the next one is going to be executed. Otherwise, there is an exception that is thrown and the workflow fail, okay? If you do not implement the try-catch approach. Now, that also works inside the try-catch. So each action inside the scope or the try-catch scope also has this particular configuration. So each action has a run after setting that we can configure. That means that even if you do not implement the try-catch scope, if you configure these actions according to what you want to accomplish, you can recover from failures. Let's say that we have a logging action. If it fails, we don't want to kind of abort the process, just go to the action below. That means that, let's say that this initial variable is the logging shape. We, on the next one, we can set up if successful, or if it's a fail or timeout, we can move on to the next action and execute to not terminate the workflow with an exception, okay? And this you can do per action. But sometimes we want kind of having a control, and we create a try-catch that we normally do. Now, another thing related with failures is that the connectors. So when we connect to a system, there may happen an error, like a connectivity error or an internal error, okay? But sometimes there are connectivity errors. And with this type of connectors, we can also have the option to have retry policies, okay? Do not raise an exception on the first error that appears, okay? And we can, there is a default retry policies that is kind of, I have 4 times with the interval period that the engine will kind of decide in that for you, but you can also set up and customize your retry policies. Fixed interval, the number of times that we want to retry to see if we recover for that failure, and the interval between retries that is specified in ISO 8601 format. In this case, PT 20 seconds. That means each 20 seconds, we are going to retry to see recover that, okay? And only finalizing the number of retries, you will get an exception and you can control that exception. Otherwise, it's going to retry. So that will also save you time and create more kind of robust integrations, not to raise a failure only if there is a timeout that sometimes you can recover after 5-10 seconds, okay? So there are many ways inside Logic App, and Logic App provides a robust mechanisms for you to control the retry policies and catch all of the exception that happens inside your workflows, okay? So another thing that when we get and control the errors is how do we get the error message? Because sometimes we want to know and log in a system the error message to analyze and so on and so forth, but also how to throw custom exceptions, okay? Because sometimes we have a workflow logic is so kind of complex that instead of having if conditions to control all of these, we can just have a condition that if something happens or a validation fails, throw an exception and go to the end of the workflow instead of having a big complex nested different if conditions. So these two questions appears often. And unfortunately, well, if you do the same comparison with C# code, throw exceptions is throw a new exception, and inside the catch, we have the exception object, and we can go to exception option.message or to strings and get the error message, okay? So unfortunately, inside Logic Apps, that is not going to be that easy. It's going to be a little bit more complex, but it's going to be possible to accomplish that, okay? So without saying more, let's go and see that, how we can, in a demo, do the try catch, but also get the error message and throw the exceptions, okay? So the first implementation that I'm going to present is using the out-of-the-box capabilities of the Logic Apps, okay? So we have a Logic App that is triggered by HTTP. We just have a kind of a demo logic, creating some variables, and then we create our try scope. Inside the try scope, there is a condition, a few more actions like setting a variables. And here, I just use a function that I have deployed in my Azure functions, and that's going to raise an exception, okay? This is going to fail. This is just a simple function that converts an XML to JSON, but actually I'm sending a JSON, not an XML. So it's going to fail. It's I'm forcing to have an error, okay? And of course, we have a catch below the try scope. And if you see the settings, I have configured the as timeout is keep it or fail, okay? And to get out of the box, the error message, we can use the expression result and the name of the action that we are kind of getting the results. In this case, is the try scope, okay? Because the only is the only one that I know that I'm controlling. And then what we can do is, well, we do a filter by status equal to fail. So we are going to go get the result of that try catch action, filtered by the failures, and then we are going to get the first error back and present to the user, okay? So I have it here, my Postman collection, and I'm just going to send a dummy, empty message, and I'm going to get a result that is an action fail, no dependent action succeed, okay? That is what we get. And now if you go to the run histories, let me just go to run histories. And this is what we get from our try scope, okay? So the try scope, it says action fail, an action dependency is not created, okay? Some error happens inside that try scope. But what we really want is this one, the XML. This is where the error failed, and the correct error message is error converting an XML to JSON, okay? So this is the error that we really want to have, not a generic error saying that something fails, okay? Because this is what we get from the response. Action fail, an action fail, no dependency action succeed, okay? But unfortunately, we could do that if we do let me go to the edit mode now. If we only put the correct name of the action inside the result. So inside the result, if we, instead of putting try scope, if you put the XML action, then we get the specific result of that action. But the problem is that when we have a try scope, there may be a complex logic inside, like if conditions with loops and so on and so forth. We don't know exactly the action that is going to fail. So we cannot put the action name here. We have to put the try scope. And out of the box, we only get the generic error that is no dependencies, an action fail, okay? So that means that we need to create different strategies. And one of the way is to create a generic logic app, for example, to get the error message, okay? In this case, we have a logic app that is going to receive the resource group, the run ID, subscription ID, and workflow name, okay? With that, is going to call the REST API, the logic app REST API, that is subscription, resource group, and we have to set up that in a dynamic way because we need to get the error of a specific run ID. And this logic app is created in a generic way that we can reuse in all our logic apps because we don't want to implement for each logic app that we have all these actions to get the error message only, okay? And you see that there is going to be several actions. So we have some initialization variables here. Then we do a call to the REST API, logic app REST API. We are going to filter the array from the failures. And then we are going to see which type of errors that sometimes can happen, different types of errors in the error messages in different places inside the history. And based on the type of error, we are going to get that information, set the body of the error body, and then return back the error message. Okay, so if you see now, we have the same logic app now, but now instead of having the error handling with the default capabilities on the catch, we are invoking that generic logic app. Okay, so now if I do the same and try the same request, okay, and send it, now the result is no longer a generic error, but error converting an XML to JSON. Okay, so if you go here to see it better in a good resolution, this was the last run, and then I got the same error, XML to JSON, bad request. It's error converting the XML JSON, and now on the response, this is what I got: error message, error converting XML to JSON. So in a dynamic way, I got the exact error message that I want to log in my system, because this is the message that gives me the details of the fail, not that the generic error saying that something failed. Okay. In this case, it is a logic app, and I'm using in here I'm using a logic app consumption, but logic app standard is going to be the same. Okay, so we actually can go for the logic app standard that I have here. And workflows. And I do have the same implementation here, okay? I have the same logic, and at the end, I'm invoking a component to get the error message, okay? Oh, come on, let's go fast. While this is opening, I'm going to show you just another way that you can also do this, but instead of using a logic app to get the error back, we can use an Azure function, okay? Just, I have here an Azure function that basically accepts subscription ID, resource group, run ID, and with that, what it's going to do is do a call to the REST API internally, okay? Of course, we need to set up the authorization to invoke this REST API and be allowed to query this, okay? And then we are going to filter that history by the failures. And then based on the error, we get the error message from one place, or we get from a different place, and return back the error message to the logic app with the exact same error. Okay, so if I do try this, and I have again here a third call that is going to be the same, but instead of calling to a logic app, a child logic app is going to call an Azure function, we get the exactly same error, okay? So error converting an XML to JSON, and again, it's going to be the same, okay? So let me see if, overview, developer design, okay? I don't know why this is slow, but okay. So again, and this is Logic App standard. I have the HTTP request, the initialized variables, the call as a function with conversion that's going to give the error, and I do have, in this case, I use the function as a function to get the error message. And again, we get this error message and it works the same. The only difference between the consumption and the standard is that consumption, we need to have an input, the subscription ID, the resource group, the logic app name, and the run ID. And on the standard, we need an extra one. We need the subscription, the resource group, the logic app standard name, the workflow name, and the run ID. Okay, just to query the REST API from logic app standard that is different from the logic app consumption. Okay, part of that, we get the same logic and get back the same error into our logic apps. And by doing that, we create a generic kind of framework to get the errors and present the errors, and you can reuse it inside all of your workflows or logic app consumptions, okay? Now, a good idea also, instead of calling directly the logic app, is the Azure function or the logic app, you can expose that inside the API management and call the API management so to be a layer of in the middle. So if something change on the APIs, on the workflow, you don't need to repoint each logic app. You just modify on the API management, and that's going to be more flexible, okay? Now, we know how to catch exception, control errors. We know how to get the error message. The last thing that we need is to know how to throw an exception, okay? Again, there is no action, out-of-the-box action to throw an exception, okay? The only option that you have to throw an exception is, for example, create an action, let's say a variable. Okay. Set a variable. Let's say that we are going to set up one of the variables and put, for example, in and put error. Maybe it's with a comma, sorry. So this conversion will fail and will raise an error, but this is kind of the way, and then you can play a little bit with the variables to set a proper error message to get this, okay? It's not the ideal, but yes, you can do this kind of stuff. Again, not ideal to have this because it has a lot of additional actions, and you're just causing something to break, not really raising in a custom exception, okay? So there is no actions out of the box to say throw exception like we can do it in C#, okay? Now, the way we can do that is, well, we have two options, or I like to use two options. Of course, you can use a logic app. For example, I have here a logic app that is, I call it common throw exceptions. Basically, I receive an error message, and what I'm going to do is return back a 500 with that error message back, okay? So basically, I'm forcing these to throw back an HTTP request with 500, and that is going to raise an exception on the other side, and with the same capabilities that we showed earlier about getting the error message, I will get this exactly error message back. So I'm getting the throw exception, that message that I raise on during my workflows logic, okay? That's a way. Another way is also to create an Azure function, a dummy kind of Azure function that it says, okay, I receive the request body, and I'm going to give back a bad result, kind of 400 or 500 with that request body. Again, I'm going to send text, raise back as an error, and then I catch that message back, and that's it. Simple as that, okay? And that's an option, and this is the option that you, let me see, kind of see here. That's calling an error message through exception. But what we can do also is to, for example, if you already have an API management, we can create an API there that do this for you. So I basically have this throw exception error here, and I have this policy here. Let me see if I can show it better, maybe later. So this is the, I'm getting the logic app name, I'm getting the logic app run ID, I get the body because I'm going to send a text with the error message. So I'm going to read that body, and I'm going to return a response with the 500 plain text with that body back. So I'm actually doing the same as I did on the logic app or as I did in the Azure function. And with that, I have a throw exception, and I can get that exception on my cat scope, okay? So if I try that now, and I'm just going to set this value instead of going to get the error by converting the XML just for throwing an exception. And if I call that back, call it again, you see that this is a custom exception from API. So if I go here on my process, for you to see it better, deployment tools, run history. You see that now it went to the right side of the condition, and it throws an exception that this is a custom exception from API management, and I got this exception on my catch, and I return it back to my postman. I return it here and say, this is a custom exception from API management. So with these kind of strategies, we can control all the errors. We can get the error message from our logic apps, workflows, no matter if it's standard or consumption, and we can throw exceptions very easily in a way that is going to be more flexible in our design of our workflows, and to reduce the complexities of our workflows, just to kind of stop it in a place or in a validation that we want, instead of having complex nested if conditions, okay? With that, that was all that I was intent to show you. I hope you like these small demos and how we drill down these error handling inside Logic Apps. And again, it was a pleasure for invite me once again to be here on the Logic App Community Day. Thank you. And if you need anything, any doubt, just please contact me. Okay? Thank you.
Thanks, Sandro. That was quite insightful session. That got me thinking that maybe encapsulating a whole set of those pieces of codes you have in a custom code and starting to create like something that it can be used as low code, because there was a lot of discussions in the comments about low code versus pro code, where both of them uses, might be an interesting solution. So it might be find out a pet project for later. Alex, do you want to introduce our next speaker?
Yeah, happy to. Our next speaker is going to be Sabahat Faria. Sabahat will be talking to us about integration between CE and FinOps using Logic Apps. So Sabahat Faria is a consultant at Systems Limited since 2022 and has an extensive experience in Azure Integration Services, specializing in integrating CRM systems using Azure Logic Apps, focusing on streamlining workflows and enhancing operational efficiency. Sabahat will show how Logic Apps can leverage from connection to Dataverse or D365 for finance and operations, and will demo how to upload data to these environments using Logic App actions. So with that, we'll give it to Sabahat.
Yeah, let's take a look.
Hi everybody, this is Sabahat. I welcome you all to Logic Apps Community Day 2024. And for today, I will be presenting you to the specific and integration using Logic Apps between a CE environment, and we have that FNO environment as well. So if we just quickly go through about me, I am a software engineer based in Lahore. I graduated in computer sciences in 2021, and since then I have been working with Systems Limited as an integrations consultant. So part of my work evolves around integrating systems using, and the system can be CRM and the FNO, and integrate them and make a unified system. The technologies I have been working on is usually Azure, and I usually use Azure Logic Apps and services buses and all that facilities that Azure offers. And using that, we design a complete environment that helps the users to have a better experience. So that's a bit about me. And if we go on to the agenda we have today, we will be discussing why do we need integration, because for now we have a lot of systems that we have integrated, and that what kind of benefits that integration in between different system offers. Why do we use particularly Logic App for that kind of integrations? What Azure Logic App offers for benefits Logic App offers for integrations. And then we will be having a short demo in which I'll be having a small Logic App flow that will be showing you how to connect with different systems and integrate these data. And yeah. So primarily focusing on why do we need to integrate 2 or more systems at first place. The main purpose of integration is to ensure that the data stays consistent among different departments. That will present a unified system to the customer, that the customer can view to access or retrieve the customer's data from multiple systems. That could be either sales department and the FinOps, financial and operation department and all that. That kind of unified system really helps the customer to have his data in place at one place rather than moving into and fro the different tabs and all that. So that will also integration streamlines the processes for data flow between one department to another, and with that the departments can have a better insight into customer interactions and how they are interacting with the system, what kind of features they're preferring, what kind of features spark their interest, how they are performing the transactions. So when we have that idea in one place about the customer's interactions, that will help us to have a better focus on a better decision making than what needs to be changed, what is going fine, what's not going, and all that. After that, we have a few business scenarios. Like that was mostly why do we need to have integration. Like these are the kind of business scenarios we have where integration really helps. So we have first, the resources are allocated in a much better way. We don't have to utilize or dedicate some resources primarily for managing the consistency of data among different departments. So once we have that integration as an automated process, then that thing we will have the resources which are allocated to the consistency, maintaining the data consistency, will be able to be utilized in a much better way. And we, as I mentioned before, we have better customer insights that how our customers are interacting, what's going fine, what's not, and what needs to be changed, what needs to be for better scenarios, what better practices we need to adopt. And then the integrated system ensures that all customers' interactions are recorded and they are reported in compliance with financial recording. And that will help in automation of the orders processing. We have different of the system. We will integrate them, and that will present a unified view, as mentioned before, as well. Then the operational efficiency is one of the most important scenarios that we need. The need for manually data transfer between systems is reduced. That saves time. That eliminates the chances of human errors and leading to overall operational efficiency. When a new customer is added, it's reflected in one department, is reflected in the other department. And for example, one customer is rated in CE, it's reflected in finance and operations and all. And with that, integrated systems help us to have a better inventory management. We have integrated systems that can track inventory in real time, aligning stocks with the customer demand and reducing holding costs. So I think that's are the basic scenarios that we can think of how integration will actually help. And for that, as I mentioned, we will be using Logic Apps to have these integrations. So what Logic App offers is, most importantly, is the built-in connectors. You don't have to worry about creating your own connectors. You can add custom connectors, but most of the needs are fulfilled by using the 800 plus built-in connectors that Azure Logic App offers. And being a low-code environment, the visual design helps to focus more on the problem we need to solve, rather than how to code the syntax errors. Basic problems like creating a connection between systems and all. So that allows you to focus more on the problem rather than the code. And it is mostly cost effective. We have main two plans, consumption and standard logic app plans. And even if you go for a standard logic app, you have the option to choose between different plans we have, depending upon the traffic you need, depending upon the CPU, RAM, etc. you need. And then you can go with your own budget you have. And when we track it will allow you, if we combine DevOps with the Logic Apps, we can usually use CI/CD pipelines. We can deploy our changes from one environment to other, and we can track the changes and have a better way to collaborate between the code and track the changes. So what Logic App offers for integration in particular? As I mentioned, Logic App has more than 800 plus built-in connectors that we can use to perform all the actions, particularly for integration capabilities. And in our scenario in particular, we have a lot of built-in connectors for CRM and FNO. If you can look at the right side of the screen, that we have built-in connectors. These are built-in triggers that Logic App offers that will basically trigger the Logic App, the ruler point that will start the Logic App flow. If you can see, we have multiple actions, like when we add a record in particular entity, and any record in that entity is added, modified, or deleted, any kind of modification is performed, we can get to trigger the Logic App flow that will have perform multiple other actions, and in the end, the record can be reflected in the other system, in our case, finance and operations as well. And if you look at the bottom right screenshot, we have the simplest way to set up the connection between two different systems. We simply have the option to have authorization, service principal, and you just need to add the credentials and it is done. The credentials is created. Now we just have to focus on what entity you need to work with, which environment you need to work with, and how the data is supposed to be shown at the other entity. We have a lot of different scenario built-in triggers to integrate that particular business scenarios. For example, as I mentioned, when any entity has a record modified or deleted, whatever, you can have the logic app trigger and it will completely perform the actions. Furthermore, we can connect the logic app with a lot of monitoring services that will help us to give us the insights about our logic apps, how our logic app or that app is performing, and how we can check the fail scenarios, how much time it fails. Based on that, we can have a report generated. We can have a retry mechanism to check all the fail scenarios, and we can notify the concerned departments that this area and this entity is being problematic. That environment is down, and different insights can be obtained from Azure monitoring services. And for the logging purposes, we can always go to table storages to have the error logging and all. And the most important part is retry mechanism. We can have our failed runs and retries in place to track every failed request. And based on those failed requests, we can determine which request needs to be resubmitted, because not every request needs to be resubmitted. If there is some data in that has problematic, if coming from the customer, we need to notify the customer. In that case, that particular request doesn't need to be resubmitted. So that retry mechanism will help you to not have a resource allocated on checking that particular records you need to retry and feed them in. So for the scenario we are focusing on is the integration between CRM and FNO. We have multiple triggers and multiple ways of integrating. I have listed of 3 of them which I prefer to use. These are blob storages. So in your code, in your environments of FNO or CE, you need to connect with the Azure blob storages from your end, and you just need to upload the data to blob in a file format, in the text format, considering in mind the limitation on this space we have for that particular blob. And other than that, we can go for service bus queues or topics. You can have multiple queues for each of the entity you have. You can have separate queues for different environments you have. In that case, I guess topics helps more, because you can have each topic for each of that environment, and in between that we can have subscriptions for different entities and all. And last is simply the HTTP trigger. You can have the endpoint, the URL of the logic app, and you can, based on that, you'll just have to add that in your codes from FNO or CE, and that will trigger the logic app. So the demo, the use case we will be focusing on, we will be having a CRM system that will push the data to our topic or queue of the service bus that will fetch and trigger automatically the logic app. The logic app will perform some data transformations, modify the record in a way that needs to be stored at the other end, and then we have the record created at the other end. After that, when we have the record created, we need to have a reference from one system's FNO to CE that we can have an idea that which record of FNO is associated with ECE and all that. So that's it, the theoretical part. I guess now we can quickly jump into the demo. So this is a basic demo I have prepared for this session. So simply, as I mentioned, we will be having a trigger. The trigger will be having a message in a queue. We will be using queues. You can have topics, or if you want, you can have a blob storage as well. Simply, we have to disconnect that queue and with your queue with here. For that, you need to have credentials that you get from here and just use them here, and the connection will be created. That's it. After that, I have a few modules to have the data. So basically, the flow will be, the logic app will be triggered using this logic, this queue, the FM by FNO or CE. You can have different queues for different environments. Then you can have some data transformations, because FNO and CE doesn't require the data in the same format. Simple example is lookups. You can have for lookups in FN, and to have pass a value for a lookup in CE, you need to pass a GUID of that particular record to have that record created against that particular record. And after that, we can have record and all that mode transformations as well, whatever you want to do. Then we can have the record created. After that, you just have to perform some error handling, which we usually do. So that's the basic structure. Jumping deep in, I prefer to receive the data in Logic App as a JSON. So the queue will be having the data in format of a JSON. You will have the JSON. You just need to generate a schema. Just paste a JSON here, and the schema will be generated based on that. Once you have the JSON parsed, you can access each and every of this attribute separately and use their values in somewhere else. Then you can compose the values for lookup option sets or whatever data transformation you need that's required. And after that, you can just have the built-in connector in Azure Logic Apps to create a record. This is a trial environment, so I don't have much of the environments here. But when you connect to an actual environment, you will be having different environments, and for those environments, you will be having different entities or tables. Just make sure that you select the correct environment you are designated to and the table name, and just simply have the values either hard-coded, or you can have this, click on this lightning sign, and the JSON, which we got from the queue, will be having all the values. So we can have this values dynamically as well. If I quickly just backsplit it. So the values will be inserted dynamically from whatever we received from the other end, be it FNO or be it CE. Otherwise, you can have a nice expression to perform some kind of transformations if you want to have something like this, to lower it to string. If you don't have any full-fledged transformations, a bit of these things can be done from the expressions. So you can add these values here as well. Just make sure that the values marked with static are compulsory, and usually if there are a few values that are necessary that are not marked as a static as well. For example, if we go to the CE FNO side, we have a few parameters that names company ID and all, which is not microstatic, but it is usually needed. So we, as mentioned, we will be having instances of these records. I prefer to have these instances stored in a more secure way, like a key vault, like parameters are okay, but while creating the connections, you can have this credentials stored in key vaults and you can access it from there as well. After that, you have entities. The bottom drop-down menu will be showing you the entities, just like here as well. And you just need to add the values from here or just what we got from the other system. So this is a parameter. So what we got from the queue as well. Then we have the company and we have advanced parameters as well. If you have something which is not shown here, you can always go and check. Use a search button bar to search that particular record you are looking for, and that's it. So this built-in connector will help you to just store add the values dynamically as you want from the CE side, whatever we got from the other environment. And just previews a bit of code view. We have the JSON format. If you want anything else, you can get it from here as well. So basically we have a full-fledged designer view, and we can go to the code view to get the JSON structure as well. That usually helps us to deploy codes to different environments. And after that, we will be having some error handling stuff, which is just minimal at this point, but we have a lot of error handlings processes and just terminate. So this is a basic structure of the logic app, which will be focusing, that will be having creating a record from one system to another, just as basic as this. It will hardly take you to like 5 to 10 minutes to complete a complete structure like that. And the integration from one system, FNO or CE, to other system will be done. Data will be deflected. So yeah, that was a short demo on how we can connect FNO with CE using logic apps. I hope you were able to learn something from that, and that will help you in future whenever you are deploying and developing such kind of scenarios. So thank you for staying with me till the end. I hope you learned something, and in case of any queries, anything you want to ask, or you just want to connect, you can always reach me out to LinkedIn. You can always will have it published as well. So it was great connecting with you people. I hope we stay connected, and I wish you best of luck. I hope you enjoy the rest of the community day. Bye.
Thanks, Sabahat. Dynamics 365 has a really nice place in my heart, because my first project in Logic Apps was when Logic Apps was still beta or preview, working with Dynamics 365, and we managed to do a whole project that connected 10 systems in less than a month. So for just goes to prove that what she was saying, that like you'll be able to do connections really quick, having the ability to use the Logic Apps to accelerate that with Dataverse. Our next session is going to be all about AI, and for that we have another visitor. So how's it going, Paco?
Yeah, good. Can you hear me okay?
Yes, we can hear you really well. So the Paco is on my side of the world. right? It's based in Australia, really close to us, and it's going to be talking about OpenAI and how we can integrate that with Logic Apps. But I'll pass to you, Paco, to do your own introduction, since you're here, and talk a little bit more about what we're going to see on your session.
Thanks, Wagner, and hi, Alex, and hi, everybody. Thanks for joining this community day. It's great to have you here. My name is Paco de la Cruz. I record this session from Australia. I'm in Melbourne at the moment, and this session is about how you can extend your Logic App solutions using OpenAI. So I prepared a demo. I hope you enjoy the session, and I'll be online for your questions.
Perfect. He beat me to it, so you know that you can ask questions. So to Paco, he's going to be online watching that with us. With no further ado, let's go to the show.
Good day, everybody. This is Paco de la Cruz recording this session from Melbourne, Australia. The title of this session is Extending Your Azure Integration Solutions with OpenAI. I'm a principal cloud solution architect. I'm currently working for Deloitte, Australia, and I've been working with enterprise integration for more than 20 years. In the last 8 or 9 years, I've been working with cloud platforms and building distributed applications on the cloud. And most of my professional career, I've been focusing on Microsoft technologies and most lately on Azure and .NET. I've also been recognized as a Microsoft Azure MVP for 7 years. And besides work, I'm married. I have 2 beautiful daughters. And besides cloud and software engineering, I like to learn about parenting, health, and body weight exercises. The agenda for this session. First, I'm going to give you a bit of an introduction of what we're going to be doing today. And then we're going to see how to access Azure OpenAI APIs on your Azure subscription. Then it's important to understand what are prompts and what's prompt engineering when trying to build this type of solutions. Then we're going to jump into a demo. Once we see the demo, we're going to see how it works. But then we're going to see also some considerations and constraints that we might face when building this type of solutions. Then I'm going to give you some key takeaways of this session. And then at the end, we're going to have some time for Q&A. Okay, so most of you should know that GenAI is revolutionizing software engineering. And this is from code generation, right? So GenAI is helping us to generate code or even understand existing code, but also to build smarter applications. And when we're using GenAI for building our solutions, this is much more than just chatbots. And we can leverage large language models, or LLMs, together with prompt engineering to make our software solutions smarter. It's also worth noting that still early days for GenAI models. And with that, really my goals for this session with you are to show you in a small scale what's possible when we're building solutions with Logic Apps and OpenAI. And also I want to inspire you to explore new ways of solving integration problems using GenAI. Okay, so how to access Azure OpenAI APIs? So first, you need an Azure subscription. Then in your Azure subscription, you need to request access to your OpenAI instance. Then you can create an Azure OpenAI resource. And once you have that resource, you can deploy a model. There are different models, GPT, DALL-E, so on and so forth. For this session, we're going to focus on GPT-4o, which is the latest, that is focused on understanding and generating both natural language and also code. Once you deploy your model, you get your endpoint and your key, and then you can start interacting with your model via Studio. So there is a playground. You can start doing prompts and test your prompts. You can also use Logic Apps connectors, as we're going to see in this demo. You can also use SDKs with different programming languages, or you can interact via the REST API directly. Okay, so what are prompts and prompt engineering? This is very important. When we're building solutions using LLM, it's important to understand how prompts work and how we can use prompt engineering to interact with these models. So we use prompts to interact with large language models. And these are natural language instructions that we craft to give the AI model a task and a context, right? So And then we use prompt engineering as an iterative process to shape these prompts or these inputs that we're sending to the AI model to get the desired outputs that we want effectively. There are some strategies for prompt engineering. First, it's very important that we write clear instructions with enough details and context to the task. We can also provide reference text or examples of how we want the output. When our task is a bit complex, we can split it into simpler subtasks. We can also instruct the model to think the tasks through. For example, we can ask the model, please provide your thought process. That helps usually with the outputs. We can also test our process, test how our prompts are working, and then assess the outputs in a systematically way. There is also a temperature parameter that we can use to determine the randomness or the level of creativity that we want for the output. In the case of OpenAI, we set it to 0 if we want it to be as deterministic and as possible. We set it to 1 if we want it to be as creative as possible, and everything in between. Okay, let's jump into the demo. So, the scenario of the demo, I wanted to build a semantic business rules engine, right? And I picked this process. So I picked the automated expense approval process to try to build this semantic business rules engine. What are my functional requirements? I wanted this business rules engine to accept business rules written in natural language, right? So this is just natural language, English. And I wanted these business rules to use semantics. In other words, I wanted the business rules to use the data, but also the meaning of the data to apply the business rules. We're going to see this in the demo. And I wanted the business rules also to support semi-structured data, so not just data completely structured. I also had some non-functional requirements. I wanted to be able to test automatically, use automated testing for my solution. And I also wanted to be able to update the business rules without having to redeploy the solution. Those were my requirements. And then when I was building this demo, I split the solution into 2 logic apps. So first, we're going to focus on the first logic app. And also, I want to share with you that all the code that you're going to see here, the workflows, the test cases, the prompts, and the test data, everything is on this GitHub repo that you can see on the top right corner. Okay, so I started building this solution crafting a prompt, right? So I prepared a prompt, giving a task to the LLM, and I was asking the LLM to behave as a business rules engine, specialized in expense approval process. This prompt also contains the business rules that I want the LLM to use to assess my expenses and then determine if the expenses is approved, if it's rejected, or if it requires a manual approval. And I'm storing this prompt in a storage account. Now, I implemented this as a HTTP-triggered logic app, where there is an HTTP client that is sending the expenses in JSON format via HTTP to this logic app workflow. Now, once the logic app receives the expense, then it reads the business rules from a storage account. It reads the task and the business rules as an LLM prompt. And then what the logic app does, it's a very simple workflow. It combines the task, the business rules, and the expense, and sends that to the OpenAI API. Right, so OpenAI API has what it's called the system message and the user message. So I'm using the task or sending the task and the business rules as a system message, and then the expense as a user message. Then OpenAI processes that prompt and then returns the assessment in JSON format. And then this JSON format is received by this HTTP client, and then the HTTP client receives a status saying this, stating if the expense was approved, rejected, or if it requires a manual approval. Okay, let's jump into the code. So let's see the workflow. as I mentioned, this is a very simple workflow. So I'm receiving the expense as a HTTP request. Then I'm reading the task and the context for the LLM to behave as a business rules engine. Right, so I'm reading it from a storage container, from a blob container, and then I'm reading the rules. And I split this. It could have been a single text document, but I split it because I wanted this to be easy to maintain. Usually the business rules are the ones that change, and the task and the context wouldn't change as often. And then what this action is doing, this is using the OpenAI connector. What it's using is calling the GPT-4o model that I deployed on my OpenAI instance. Then it's sending as a system message the task and the rules, right? And then it's sending as a user message the actual expense payload. And I'm setting the temperature to 0. The LLM will return this assessment based on the prompt. And then this is returning the assessment output as a JSON document. So let's have a look at the business rules and the task. So this is where I'm giving the task and the context to the LLM, right? So I'm telling the LLM, you behave as a business rules engine that specializes in expense claim approvals. You receive expenses in JSON format. You will assess the expense against the business rules and return the response in a valid JSON document. Then I'm giving an example of how I'm expecting the JSON document to be structured. I'm explaining also how to the three statuses that it should return, either approved, rejected, or requires manual approval, and then a reason for that status, right? And I'm asking, when you're returning this status reason field, state clearly the rule that you applied, including the values in the claim that were used for the assessment, and explain in detail your thought process, right? So I'm following some of the prompt engineering strategies here. So this is the task and the context. Now let's see the actual business rules for the expense approval process. So I'm asking the LLM to assess 2 types of expenses, flights and meals. For flights, I'm asking the LLM to check if there are domestic flights or international flights. And I'm asking to check if the employee type or employee level is a boss or not a boss, and also to check the amount of the expense, right? So depending on that, then the expense related to this flight should be either approved or rejected, or manually approved. For example, expenses of type flight that are for a domestic flight within Australia and the employee level is not boss, these are never manually approved and must be approved when the amount is below or equal to 1,500 AUD, and must be rejected when the amount is greater than 1,500 AUD, right? So I'm specifying the full business rule. And then I have different combinations of the different values, right? Those are for flights. For meals, what I'm saying is, if the expense occurred during a weekday and the employee level is not boss, then they must be approved if the amount is below or equal 50 AUD, or rejected when it's greater than $50, right? And so on and so forth. So I have all these business rules for these expenses. So now let's test these from Postman. So I have this an expense that I crafted for testing my business rules engine, right? So in this case, my employee level is manager. I'm specifying a date and amount and description. Let's send it to the Logic App. Returning approved, right? So it's returning approved, and then the status reason saying expense of type meals occurred during a weekday, and then the employee level is manager. The amount is below the threshold, right? So it's returning in detail why it gave me that status, right? So now there are some interesting facts here. The first one is, I didn't specify to the LLM how to determine if it was a weekday or a weekend, right? So the LLM, based on all its training, was able to make this deduction of saying, okay, based on this date, I know that this is a weekday, right? Now let's send it for a weekend. So this date is a weekend. If I send it, then this is saying this requires a manual approval because this occurred during a weekend, right? So again, the LLM, based on all its training, right, was able to make these deductions. And interestingly, so if we compare the first request and the second request, the first request has a type field, which is meals. The second request doesn't have that field. But still, the LLM was able to deduce the expense type based on the description, right? So this is where this business rules is becoming like a semantic business rules, because business rules engine, because it's taking also the data and it's meeting to make these assessments. So now let's go to flights. So what I'm sending here is employee level, type flight amount, and then description, right? And in this case, for example, I'm saying in the description, round trip from the Brisbane airport to Dallas Fort Worth airport. And the LLM was able to make this deduction saying, okay, based on these airport codes that I could understand in the description, I could deduce that this is an international flight, right? So again, I didn't specify exactly how to know if this was an international flight, but the LLM, based on all its training, was able to make these deductions. And this is, again, one of the features of this semantic business rules engine. So this is from Sydney to Auckland, for example. So it's an international flight. This is rejected based on the amount and the employee level. So let's go to a domestic flight. So this is from Melbourne to Perth. And this is rejected, but it's telling me this is a domestic flight. All right. So now, one of my non-functional requirements was to be able to apply automated testing here for my business rules engine, right? So I crafted these test cases. So all these test cases we saw in Postman, I saved them as part of my C# test solution test project. I'm using XUnit here. I'm using theories. I'm loading all these files to apply to run my tests, my test cases. It's a very simple test case, really. So reading first in arrange, I'm reading the file. Then on act, I'm sending the request to the Logic App. And then on the assertion, I'm checking if the status is as expected, right? So I'm asserting if the status is as expected. This is expected. I'm not assessing the status reason because status reason is open text. It's just natural language. So it's very hard to assess, but I'm assessing the actual status. Let's run my test cases and hopefully all of them run. We just need to bear in mind that sometimes LLMs can hallucinate, right? So, but I wanted to test with these expenses, my solution was working. And again, I had to tweak a bit my prompt to make sure that it was enough for the LLM to do what I was expecting it to do. Perfect. All my test cases passed. All right. So this is the first Logic App, right? That encapsulates the business rules engine. So we go to, we can see the last executions here. So these are all my test cases. So So we can see it received my expense, it read the prompt, then it read the business rules, it sent both the system message and the user message to the LLM. Then the LLM returned the actual status, right? So status and status reason, and this is what's returned to the HTTP client. All right. So that's the first logic app workflow. The second one, I just wanted to do it to use it in the context of an integration solution, right? So first logic app encapsulates a business rules engine. This second logic app is kind of an end-to-end integration solution. So what it does is it receives expense claim documents in JSON format in a blob container. Then this is triggering the logic app. And the logic app, the orchestrating logic app, is going to call the business rules engine. That's going to read the business rules. It's going to combine that with expense. It's going to send that to OpenAI. OpenAI will return the JSON. And then based on that JSON, this orchestrating logic app is going to save the expense file in an approved, manual approval, or rejected folder, right? So we have 3 subfolders in the output container. So let's see the... So I have an input container and an output container. My output container should be empty. And then let's check that other workflow. So this workflow is triggered when an expense claim is added to the container. It reads the content. I'm parsing it to be as a JSON with tokens in my low-code environment. Then I'm going to call the other HTTP triggered logic app that encapsulates the semantic business rules workflow. I'm going to parse the assessment as a JSON format, again, to be able to use the tokens. Then what I'm doing here is I wanted to have a single payload that has the input and the output, and this is just for me to see how it's behaving. And then I'm deleting the original expense claim from the blob container, from the input blob container, and then I'm saving it in the output blob container. And then I'm using the status field as a subfolder here, and then saving the actual JSON document. So let's run it. So what I'm going to do is I'm going to upload my expenses to the input container. Oops. So I'm uploading here 12 documents. These documents should trigger my logic app. These are the instances, these 12 instances, 12 messages. So if you see here, it's getting the actual expense, reading the reading the actual content, and then calling the other workflow with the actual expense body. And then this one is returning the actual assessment, right? This one required a manual approval, the status reason, and so on and so forth. Then I'm composing a message that has that is combining both the input and the output. Again, this is just for my own testing. Then I'm deleting the original message, then saving the output to the corresponding subfolder. So if I refresh, this input blob container should be empty now. If we go to the output folder, now we have output container. Now we have expenses that were approved based on the business rules. We have expenses that were rejected based on the business rules. And then we have expenses that required a manual approval, right? So this is my end-to-end solution. All right. That was the demo. Now, I wanted to highlight the semantic features of the GenAI-based business rules engine. As we saw in the demo, the LLM was able to make some deductions without having explicit instructions. So it was able to deduce if it was a weekday or a weekend based on the date. And I didn't explicitly state this rule. It was able to deduce if the flight was international or not, or a domestic flight, using airport codes in the description field. Again, I didn't specify how to do that. The LLM, just with its own training, was able to do it. And then the expense type was inferred using the description field when this field was not present, right? So this is kind of the semantic features of the business rules engine using OpenAI. Okay, well, in this case, the demo worked, right? And all my test cases worked okay, everything was green. But it's also important to think that this was just an experiment of what's possible. This is not an endorsement or replacement of the Logic Apps business rules engine, for example, or I cannot guarantee that your business rules engine is going to work 100% of the times. And that's because LLMs and natural language introduce some challenges, right? So first, LLMs are non-deterministic. We set the temperature to 0. So we were asking the model to be as deterministic as possible, but that doesn't mean it cannot hallucinate, right? Natural language can be ambiguous, right? So the way some people might structure the business rules might not be super clear for other people, right? There is also complexity. Imagine debugging, like there is no way to debug the business rules. Once we have the prompt, we cannot debug what's happening inside. It's hard to troubleshoot. It could be hard to maintain as well. There might be some inefficiencies, right, by introducing an LLM in the middle of our integration process. And yeah, again, we could have unexpected outcomes, having hallucinations. Sometimes we could receive something that sounds like a text or an output that sounds plausible. It's like a sound explanation, but it could be completely inaccurate, right? Now, we were able to test the business rules engine, but just the status field, right? We couldn't test the status reason. So, I mean, we could test to some extent the outputs, but it could be challenging as well. Now, many of these SDKs and connectors are still in preview, so you might have some limitations again. And we're still in early days of GenAI and large language models. Key takeaways of this session. Well, as we saw in the solution or in the demo, Logic Apps provides a connector to interact with OpenAI in a low-code environment, right? So we can extend our Azure Integration Solutions with OpenAI and build smarter applications, right? GenAI can help us to build intelligent apps beyond chatbots, right? So in this case, we were able to create a semantic business rules engine using the LLM, and this was not a chatbot, right? It was a completely different use case. So we can use prompt engineering and LLMs to perform AI-augmented tasks within our Azure Integration Solutions, as we saw in the demo. And the semantic business rules engine, just one of the many potential use cases, right? Your imagination is the limit, really, and the limitations of the LLM. But we can definitely use LLMs for different use cases. There are some challenges and some constraints that we need to consider when using GenAI. And last but not least, I hope this demo has inspired you to try and experiment with different use cases for your own projects. Well, I want to thank you for watching and staying with me this session. Again, this is Paco de la Cruz.
Thanks, Paco. That was a really interesting session. Even I had some questions on the chat, and we are now down to the last session of the day. So I'll let you do the honors, Alex, to introduce the last one.
Alrighty, our last session is going to be Mick Badron. Sorry, excuse me. And his session will be about using AI in healthcare through Logic Apps. So Mick is an Azure MVP with over 20 years in the MVP program and founder of Solve It Today, which excels in delivering high volume, near real-time scalable solutions with a strong focus on Microsoft integration technologies. So Mick will present a real-life use case using AI and Logic Apps to implement healthcare solutions that include taking vitals from the field, AI-driven diagnoses, helping to create a more encompassing toolkit to assist health service providers in decision-making. So definitely a very interesting session. We're very excited to have him over.
Yes, so let's add that last session.
Hi and welcome. I'm Mick Badron, and I'm here to talk to you about integrating AI into your healthcare-based solutions through Logic Apps. So come on and let's get started. So just to give you an idea of who I am, basically I've been integrating for over 30 years and have previously been involved in a healthcare startup. And I'm an MVP and I love what I do. In terms of who keeps me motivated and the people at home that are shining lights in my life, there are various people and various characters and actors, and that there is my dog, who is the only one that really listens to me. And just as a little nugget, a little while ago, I swam from Bondi Beach around to Watson's Bay out into the ocean as part of an ocean swim that I do. So I really, that's the thing that is my space and gives me my thinking time. So what I'd like to show and talk to you about today is just a little bit about the adventure that I've had over the last 4 years and talk to you about AI and how to apply it and even where to start and what are some of the things that we want to know about, or how do we even look to get started and some of these key decision points. And I'd like to then just share how I applied that into healthcare. And, as we start to see the evolution of AI, it's sort of, deemed to be taking over the world and everything else. But what I'd like to do is show you how I've applied it in a sense that doesn't take the decision-making away from the healthcare professionals, but really just enhances what they do. And obviously at the end of my presentation, I've got my contact details and things, and I'd really love to hear about your journey and just how you're going and some of the questions that you may have along the way. So how do you start? And, as you've seen, the noise, and there's a lot of information, and even week by week, things change significantly. And AI is a tool that you can use to help you get to your end goal. So start simple. What is that end goal? And, certainly don't try and boil the ocean, as we say. Don't try and do everything all at once. Have a look at where you want to get to and start to have these incremental improvements. And the other thing is too, that as we're using AI, unlike a lot of cloud services and the like, these costs are significant, and we do notice them, at the end of the month. So plan it well. And, I'm sort of the opinion, get out there on the field and start playing the game, and you'll learn a lot more than watching it in the stands. So really just sort of have a think and put one foot forward in front of you. So just to let you know how I arrived at where I am today. So basically worked in the aged care space and then devised a solution around remote vitals capture. So blood pressure, temperature, oxygenation, UTI, glucose, various things like this. And so being able to help people at home and stay at home longer. And over here in Australia, there's very much a doctor shortage. So we just can't get enough people face-to-face time with doctors. And so this is a solution that helps to address that space. And then there's other things around wound care, which is another important aspect here in the medical system, where how can we treat it? How can we manage it? And we also want to be able to monitor and see how it's going. So what this solution looks like is essentially there's a range of different devices, and some of these take your ECG, and some of them take your pulse oxygenation and so forth, and look down your throat. and that's connected to a mobile app, which typically these devices connect over Bluetooth. And essentially that gets pushed through into some sort of portal, some sort of dashboard that doctors, nurses, family members, and so on can see. And these things can be tracked over time. So what I really wanted to do was be able to enhance this sort of experience and really draw upon the wealth of knowledge that AI tends to give us. And it's a little bit like when I was a kid, my mum used to have a set of encyclopedias on the shelf. And once I sort of knew what we were after, we'd go over and sort of look up whatever that topic was in the encyclopedia to come back and sort of enhance what we're writing. So this is very much in that space. It's not about necessarily taking or making a decision. It's about saying, well, you know, if I've got this in my blood pressure, these readings, or if I'm this temperature, or here's my heart rate consistently, what does that mean? Or let's have a discussion about it so that it can start to enrich the conversation that we have. And then in terms of the other half to this solution, there's very much a teleportal, a telemedicine portal, which relied on, built through Azure Communication Services, things like audio, video, language translation, so that as people get elderly, they tend to revert back to their native language. And so that there was the ability to have a conversation where we translated the conversation between Italian and English and back again. And so one of the other areas was things like progress notes. So doctors would take down progress notes, and certainly being able to include those into the conversation and translate their scribbles into something more meaningful. So that was kind of the premise of the solution I spent the last several years building. In terms of where we'd like to start with AI and how to frame it, I tend to think of it as a calculator, except, you know, these days we have more functions than what we had previously. And in terms of the AI calculator, it does some things really, really well. It summarizes, it translates from one language to another language. You know, and there's a variety of different things that it does, and it's expanding all day, every day. One of the things that it's not good at is, let's say you might be a lawyer and you could ask it, digest all my case material and come up with my opening arguments. It doesn't do that. My experience is it doesn't do that at this point in time. We've still got to put those nuggets in and formulate the plan, but it can certainly come around and pad it out. So in terms of, you know, the calculators and things, originally way back, we had these Casio, they were solar powered, and they did, you know, 5 + 3 = 8. And then we moved on to sort of the HP Revolution, and they had this reverse Polish notation, and you supplied 5, 3+, and it came up with 8. And then so now we have our AI calculator that tends to know everything about anything. And obviously the context around it is super important. And so I'm really excited as to where this space will go, how it will be used, and, you know, just how this calculator evolves. And at the core of what we're dealing with, we've still got a model. We've still got some sort of function, you know, y = some function of x, and x can be, you know, quite detailed, but it's still a function. And as a side topic, you know, what, in my mind, what denotes intelligence versus, is it just a really good, what word comes next, picker? So, you know, that's for another time over a campfire conversation. But in terms of, you know, some of these models that have evolved, and there's thousands out there at the moment, some are very good at working with text, some are very good at working with sounds, images, you know, looking at code and working out, is this good code and optimized? And obviously as developers, we get exposed to that quite a bit. And then we have, you know, things like a training set. So here's how I want you to behave in these situations. And we have other components such as an encoder, taking inputs from the outside world and producing them into a format that's conducive to the model and the model type that we use. And then the decoder is the component that takes that inner workings from model speak and model language out into something that we can understand, more readily. And so it looks a little bit like this, where you've got your training set as number one, and the model is stored there at point 3 on the list, and we've got a series of words, and they have basically a marker after them, or what they call a vector, which indicates, if you think of it as a 3D space, whereabouts that this model has seen that word in space. And essentially it stores it in an optimal way, so that when we ask the question at number 5, we get back a reasonable answer that comes back. So, that's a very short version of it, but that's kind of the fundamentals. The question really is, how do I know if I've got the right model? How do I know if it's a good model or a bad model? Do I just go with the flow? So, these are really important questions. And typically I've found that about 8 months in, you'll figure out, that's when you start to find out how your model is really performing. So in terms of how we sort of go about these things, I tend to regard it as creating a cake, for example. At step 1, as you're progressing your journey through the AI world, you're sort of in the pantry there, pulling out all the different ingredients that you think you might need to make a knockout cake. And you're gonna reach far and wide, and you're going to experiment. You're going to pull back all the things that you didn't, that you want to just sort of try and apply and everything else. And then at step 2, you start to sort of refine all these different inputs and all these different things that you've got to start, and the cake starts to take shape. And then really step 3 is you've got 80% of the cake built, and you'd then like to just add a little bit to it, a tiny bit there and a tiny bit there. And a lot of that is like what I see, applying AI to your business. So at the very beginning, you're sort of saying, well, we want to know everything about everything. But then really, if it's a chatbot, or if it's something that appears on a website to help people navigate your product catalog, for example, it's really a very fine, refined space. It's about, how many red jumpers do we have in a medium size, or what's the delivery on this? So it's a very much a focused area that we have. And so we tend to sort of I look at that as specialization. So we don't actually need to know everything about everything. We need to know everything about something as we refine further down. And so the 80-20 rule in my mind is beautiful. That let's get started with 80%. Let's get out there on the pitch and start playing the game. And we're going to learn as we play each game. And then we can really get down to, refining that last 20%. So we've heard a lot about large language models, and, once again, it's anything about everything. I want to go and ask it a question about absolutely everything. If you think about applying it in your business and in your workplace, right down, by the time you get it out to production and deployed, you're not asking everything about anything about everything. You're asking it about a very refined area, not where you were previously. And so in terms of, the alternatives or something that we're seeing coming out, we've got small language models. And it's, as I say, it's anything about something. And these small language models can have 7 parameters, and they perform very, very well. They're light, they can run on a laptop, they can run on your phone, they can run on devices. So, certainly watch this space, because that will be a significant evolution. In terms of where I applied this in healthcare, basically from that mobile hub, there was a series of different observations or vitals that were captured, and built on Azure, and I used some IoT hub type aspect to it, forward those results off into something that was able to process that a little bit more intelligently using OpenAI, the APIs of OpenAI, produced a PDF report that was, here's where the details that your blood pressure was this, your temperature was that, and so on. And then obviously there was some database work, and that was all wrapped up under the robustness of Logic Apps. So what I'll do is just I'm just going to switch over to a demo now and show you where we can take this. So I've just brought up my screen, and the first, excuse me, the very first thing that I would do is typically just come and have a conversation. Use the likes of ChatGPT or whatever you've got access to. Just come and have a conversation, because often it's how we formulate the question below there, which is, what does high blood pressure mean? Our prompt is often the challenge. And the thing that I find personally that I have trouble with is that, depending on the model and even depending on the week and what deployments and updates have been done, some of the prompts will work and some of them will not. Namely because I get back, I'm not a healthcare professional and I can't answer that. So it depends on, the journey, and it's quite an interesting one. So if I supply, what does high blood pressure mean? I'm having a chat. So in other words, is this going to give me roughly the type of information that I need? And can I come through and take this further? So once I've sort of happy with what I've got here, I can move over to other things, such as a tool called LM Studio. So LM Studio is a locally run application that allows me to go into the Hugging Face repository of all the different models. And I've just done a little search here on a model that I might want to use, and I can run this locally. I can also come along and set up and start a server so that on a local host of port 1234, it answers. It's a server, and basically I can use the OpenAI SDK, etc., to talk to this. So it's very much in my own local sort of environment, and I can start to play around with models, languages, see where I go. But the problem is too, that how am I going to answer which model out of all of these is good for me? So this is a local application, this LM Studio. You can go and grab it, free, and start to play around and experiment. And you've got, various things here. So before you start to take it into the outside world, this might be a place that could be handy for you to work with. So the next step would be to then come into something like Azure AI Studio. So it's really handy, and I can set up a project. I can start to tie together a lot of things if I'm looking at writing co-pilots, if I'm looking at agents, if I'm looking at trying to shape my conversation a certain way with assistants and various other things in here. One of the parts that I really want to just sort of draw your attention to at this stage is, if I come down and look at this model catalog, it'll come back with, when it does, it'll come back with a similar model to what we cataloged, to what we saw with LM Studio, and having a whole bunch of different options and choices that I might want to be working with. And there we go. It's just waking up. And I can go through and look at my different filters on the different models that I want. Now, the part that pay particular attention to is the one underneath, which is the model benchmarks. And the model benchmarks, just from an outset, gives me indications of error margins and performances, and also just how these models relate from one to another and where they sit. And there's things like cost, performance, accuracy. One of the overriding factors on any model selection is really accuracy. So you can do a lot of things. If it's not accurate, then that's one of the major weighting factors. So we can come along, we can have a look, and there's a whole series of different models. You can refine this view. Handy to keep an eye on. So once I jump into my project playground, I get a similar sort of experience to what you saw with LM Studio there, and even ChatGPT, where I've got the ability to go and to go and chat and and talk and select my different models that I want. So I can really start to play around here. And, you know, what does high blood pressure mean? And there we go. And, you know, see that sort of stuff take off. Now, the other part here is I can jump in and view code. So straight away, I'm starting to bring this closer into my end solution. And so I've got that you know, code that I can drop in. The next service that I'd love to sort of show with you and share with you along the way was text analytics for health. And I've wrapped that up at the moment. And I've wrapped it up as an endpoint, and it's nothing too dramatic. But I've got a sentence here from a doctor, for example, that says take 4 capsules, 10 milligrams, Stemetil twice daily. Now that doesn't make sense on the particular medication, but what it does, if you think about doctor's notes and things, I'm able to extract out some pretty interesting aspects on those doctor's notes. And I'll just sort of drill into that a little bit here for a moment. And you can see there that I've got the dosage, I've got the medication name, I've got the frequency. So what might I do with that? Well, what I can do is I can come along and in Australia and certainly in the States and things, and I'll just sort of make this a bit bigger. There's drug databases. So I can now come along and I've got a local sort of copy of a drug database. Nothing too dramatic. It's public information. And what I'm able to do is now to go off and run a query and essentially say, you know, give me back some more information about this drug called Stemetil that you may know about. And so now I can start to work with the medical system and the pharmaceutical system to work through what the side effects are, what the known allergy, you know, if I've got known allergies and other bits and pieces. So I won't worry about that to come back for the moment. And then in terms of being able to create a report, the best way that I was able to do this, and the easiest way, was to come through and use Logic Apps. So with Logic Apps, the most important piece here, I've got some observations that I send through. So basically, this is from the mobile device through to the end, and it goes away, and I've got an HTTP call to OpenAI. And the reason why I've got that is because, yes, there are adapters in Logic Apps, but this gives me the most flexibility about how I'd like to shape my call so that, because I'm experimenting here, I'm still making that cake and I'm trying to sort of figure out what the best way to sort of present this and then get back the results. And I return back the results to the caller, and then I go away and create a PDF. And I'm just going to jump into Postman here for a moment. Apologies for all the fantastic tools that are popping up in front of you. And so now if I call this, and I've got some data here that essentially a way that I've shaped my particular request. So I've got my name at the top, which is just, there we go. So I've got my name, I've got my address, and then I've got these observations, and they tend to sort of start to fall into medical speak. And I've got my blood pressure and a couple of observations there. So now I'm going to send it and run it, and that's going to call that Logic app that we were just seeing a moment ago. And it comes through and it shows me some details about pulse oxygenation, 89%. Is it good, is it bad? So here you can start to see, I've already got the result from somewhere, but what I'd like to do is really get some additional information about it and what that means. And then in terms of that process, here is the PDF report that was just created. And it's very rough and ready, but there's the pulse oxygenation. And then here is my blood pressure, and it talks about it, potentially being high, low, whatever. And this could be made into something a lot more beautiful than what you see in front of you there. So that's sort of the quick run through on that side. And what I'd like to do is just finish up with just talking a little bit about wounds and how I applied wound wounds to AI to wounds. So basically, really hard to get size of a wound, and essentially these characteristics are particularly important about, you know, what type of wound is it, and also the healing nature of it and things like that. And so let me just grab my prompt. And so if I want to have a look at this, so this is probably the harder aspect of it for me. I'm just going to go back into my AI Studio, because often the prompts will get caught, or the notion. So I'm just going to upload that image now into my playground here. And what I'd like to do is have AI comment on that image. And that image sort of says, well, my prompt is, if the circled wound is healthy, classify the rest using standard wound classification and mention the estimated healing time. Let's see what happens. And so now when I run it, it's going away, and it'll come back and give me quite a detailed response. And, you know, based on the image, it gives me some good things in here, but I won't go through them all. But it says, you know, top left wound is this, description, estimated healing time. So you can start to see that it's not just a picture anymore. And for me to get this level of detail outside of AI with image classification and things, I'd need approximately 200,000 images in my sample set to train them. So that there, you can see I can really bring that out elsewhere to reports and to other things to really, you know, highlight and use AI. And then obviously the part that I love about AI Studio, I can come along, view code, and there's my code to implement and to embed this in my, you know, in my solution somewhere. So, you know, as I mentioned before, I'll just show you this quick one. In terms of the wound sizing, what I did was apply just some of the video techniques that are out there in the industry, and I've developed, this is just an app. I've taken a quick recording of it because it relies on the camera, and while I'm presenting here, the camera is going to be in contention. So basically, with all the AI and everything else, it's really hard to get sizes of objects in images. And one of the really important statistics is being able to get a size of a wound. Now, what I do is, here is just a basic Windows app, and I've got some sort of video editing capabilities underneath it. The top left image here view is the actual image. The bottom left is what I do. I apply various transformations to the image to get edges and things. And then this is the information superimposed over the top of it. And then as I'm working through, it'll detect all the objects, and you can imagine it'll detect the edges of a wound and so on. And then the part that gets important is when I hold up one of these, which is a marker or a tag, that one there, you can start to see the screen goes full of green. And what that is essentially all of the polygons have now got their sizes, and I can work out, because I know how big this image, this marker is, I can then work out the size of these things and the size of the wound. And, you know, as we sort of view it over weeks or over time, we can see the wound reducing and healing nicely. And this marker is along the lines of what they do for, you know, crash test dummies or people doing videos, and they put them on their arms, elbows, knees, and things like that. So just really to kind of give you a bit of an idea of some of the variation of things. And just to kind of give you a wrap up now, you know, AI, treat it like a calculator. You've got some functions. It's not perfect. It's not brilliant, but, you know, don't let it make the big decisions for you. Just enhance what you've already done. And I'm a firm believer on that 80%. Get out there, get the 80% done, because that's the easy part. We all know that last 20% is where it's worth its weight in gold. And then, you know, how do you know a model's a good model for you? Try a couple, have a look, do some research, LM Studio, AI Studio, whatever tool you like. And, you know, set some clear goals, have some fun while you do it, see what's there. And, you know, certainly Logic Apps is a great enterprise platform that's going to give you that scalability and that robustness and that resilience around whatever you do. And you saw there that I had a designer, and that basically it's very visual. We could go a lot further than that, but it's very visual. It's easy to sort of get up and running and get going. And thank you very much for your time. I'm Mick Badron, and I hope you've enjoyed it as much as I have.
Thanks, Nick. I know that I enjoyed. It's always a pleasure to see you talking about those other hot topics. I think we get to the end of our show, Alex. People stay with us for almost 5 hours. Thanks everyone to watch that watched, and remember that we're going to have all of that available on YouTube on the Azure Developers channel, and we're going to have a playlist of each of the individual videos starting to pop up on the channel next week, right?
I believe so.
Yeah. So with that, I think it's time to say goodbye. Thank you, everyone that joined us, and until next time.
Thanks, everyone. See you next month.
Bye-bye.